This
Then the
conference
cluster
will now be
components called
recorded.
master components, node components, and then we have covered how to deploy a pod into the clusters, right? Then the properties, the other information about the pod and those things we see, right? So today we'll see the other components, the other areas of the cluster, Kubernetes cluster, right? So here, if I go to the cluster and if I ran kubectl get pods, right? The get pods are nothing but getting the pod, right? Pulling the pods from the namespace, correct? So every resource is going to allocate to a namespace, right? So now here, whichever the namespace will be set as a default. So when you ran the commands, it will go and fetch the particular namespace, right? We have seen that one also, how to set up a namespace, set context. And with the help of set context, you can change, I can switch, or you can set up your own namespace as a default. Otherwise, every time when you are going to run the commands, you need to provide the namespace details. Correct? So now here, by default, the namespace, I'm not having any resource because in our last class, I have deleted the parts also. Right? So now, if you observe here, in the default namespace, I can see there is a Nginx pod is running. You can see here, it is up and running one by one. Right? So if you want to see the control status, right? The controller is the master component, which is going to make sure what is the desired state and what is the current state. If the state is matching, fine, let's leave it as it is. Otherwise, take care of the to bring up the matching state. Let's kubectl get rs. Right? RS means replica sets. So here by default, it is switched to, sorry, I mean say it is pointing to the our own namespace. So here I am going to change it to default. You can see here desired count is one, current is also one, that is also right. The controller is good as typical. Both what is the desired, what is the current, both are matching. Right. So now here I would like to access. I would like to access this service into the outer world. Right. So how we are going to access this one? So if you want to access the services which are running inside the cluster, by default, those will be private. By default, those will be private. You cannot access. So for that, you need to provide the access so that the people or whoever wants to access the service to the outer world, they can access it. So how can I access it? Right. So now this access, I am going to correlate with a Docker. Right. So when you are trying to run any Docker container, means when you are trying to create any Docker container, correct? So by that time, if I'm not providing any -p port expose option, that service I cannot access into the outer world. Correct. So now here, when I want to access the service into the outer world, then I need to provide -p, right? Your port number colon the container port number, so that whatever the port you are trying to expose with that port, you can access it. The same funda here also. So whatever the service, I mean to say whatever the software, the app which is running inside the container, means now here the technical term is pod. Inside the pod, if you want to access it, means you have to provide the access. But we have to provide the port number. You need to expose the port number. Okay. So now here, what I'm going to do here is I am trying to give, or I am going to trying to provide the port number to my Nginx container so that I want to access it. So let me go to the cluster. kubectl expose, kubectl expose, deploy nginx. Now here hyphen port 80, then hyphen type node port. Okay, we'll discuss this node port thing later. So now let's try to understand this one. expose, right? I want to expose. Which you want to expose? I want to expose the deployment, right? Deployment I want to expose. Which deployment? Nginx is the deployment. Nginx deployment I want to expose. So with port 80, right? So now here it is throwing an error. So anyone can tell this reason, error, why it is throwing this error? Here Nginx is running. ఉన్నారా లేదా?
Not sure, sir.
So yeah, uh, okay, fine. One thing I would like to understand, you guys are able to following me or not? At least you are able to understand this concept or not?
శంకర్ నేను చెప్పింది ఇప్పుడు ఆ ఎర్రర్ ఎందుకు వస్తుంది అర్థం కావట్లేదని. See, we're following the class as far as I'm concerned, it's all good. ఆ ఎర్రర్ ఎందుకు వస్తుంది అనేది అర్థం కావట్లేదని క్లాస్ గురించి కాదు.
నాకెందుకు డౌట్ వస్తుందంటే, మనకి అది ఇన్ కేస్ మనకి క్లాస్ ఫాలో అవ్వకపోతే ఇదంతా మనకి మిరాకిల్ గానే ఉంటుంది యాక్చువల్ గా, ఇదంతా ఈ కాన్సెప్ట్స్ అన్ని కూడా. సో అందుకని నాకు మళ్ళీ అక్కడ ఆ ఏరియా డౌట్ వచ్చింది అన్నట్టు. ఓకే ఫైన్. సో okay, let me explain this.
I was saying something.
Yeah, Teja. Yes, Teja.
No, nothing, Shankar. Go ahead.
Okay, so that's what, guys. Starting of the class itself only I have explained this reasons actually, right? So what the process is here, let me try to explain you one more thing, because Kubernets is very, very important for the DevOps right now for us. So here, let's try to understand in this fashion. Yes. Right, so now this is my cluster. Okay, this cluster is having multiple nodes, means multiple servers. Okay, that can be like 3 node server, a 3 nodes cluster, or 2 nodes cluster, or 5 nodes cluster, whatever it may be. Let's assume this is my cluster. So in this cluster I have master node and what is called, okay, let me write that one also. Master node, and right now we have node 1 and we have node 2. Now this is my Kubernetes cluster. So now here, as I said, if any component, here the component means, let's assume a containers as of now. So any containers means the parts. Any parts you want to deploy into the cluster, basically we require the thing is namespace. So right, so now here this is my namespace. Right, all the resources, whatever the resources you are trying to launch into the cluster, you require a namespace. Right, so we have seen that one also. By default, we are going to see the namespace when you set up the cluster. The namespace are default kube system, kube public. Right, so kube system is the namespace which is going to hold your cluster components. What are the cluster components here? Our DNS components, proxy components, right? So whatever you have master and nodes are there, whatever for to maintain those master and nodes components, you are it's going to create a parts. With the help of parts only, those components are going to maintain. So that will be resides under the namespace called kube system. Right? System components. With the word itself, it is going to tell us it's a system components, the cluster components. So now here we have a namespace called default and public. Public will be used for in a separate case. When you are trying to deploy your components, like your means our, like whoever is going to work on the cluster, those components will go into the default namespace. When until unless you have created your own namespace and you are pointing to your own namespace. Until unless, right? Until unless if you are not having any namespace from your end, then it will go to the default namespace. Right. So now here this is my namespace. Suppose let's take it. This is the default namespace. So now here whatever the containers means the part I am launching, those will be deployed into the any one of the nodes, either this node or this node. Right. So now we're under a namespace default. So now here let me go back to our Right? ns is the command to see ns list. Right? Here we have created this dev env in our last class. Right? So now here we have, apart from the default public and system, we have our own namespace. Now let me draw that one also here. So now here we are having one more namespace. So we are discussing about our components, not about the system component. That is the reason I am not pointing these two. Right? So now this is the default, and here our namespace dev env. Okay. Right. So now here, right now, to manage our components in our cluster, we have two namespaces. One is the default, and second one is the dev env. Right. So now here, what I'm trying to do here. Right. So here, kubectl get pods. I am not seeing anything. So now get pods -n default. Right. So now here clearly it is showing get pods. Right. By default, we have default means we have in our last class. I have switched my default to dev env by using set context. So now here my whatever the kubectl commands I am trying to run, that is fetching those commands are go and fetch into the namespace called dev env. So that is the reason when I ran the command normally, it went to the dev env. There I don't have any pods running, any content server. Right. So now here the default, when I pointed to the default namespace, there I can see a pod is running. Right. So now let's go to the diagram again. Right. So now in the default, a pod is running, and in the dev env, nothing is running. Now the dev env is the default one, because we have switched to the dev env in our last class. Right. My kubectl command will go to the first default dev env. So now here, when I'm trying to run this command, maybe that is gone. Let me take the command again. Now when I'm trying to run the command, that I am telling my kubectl command, right? The nginx is running. Now I want to access the nginx into the outer world with the port 80. Right? Expose means expose, right? So that I can access it. So now here it is throwing an error. Now tell me what is the reason.
Devin env లో pods ఏం రన్ అవ్వట్లేదు కదా శంకర్. I think that might be the reason we are not able to launch it.
Exactly. That is the correct answer. That is true. Right. So that's all, because as I said, my kubectl command always pointing to my namespace called dev-env. So now here if I go to right, so here I am trying to tell go to this dev-env, then whatever the container is running with the name nginx, expose that nginx container, nginx pod. But here no pods are running. The pods are running on the default namespace. So now it is not able to find anything on this namespace. So that is the reason it is telling I am not able to find any nginx deployment. Simple. Right? So likewise, you need to think about like where the pods are running, like which namespace. If you are seeing this kind of error, means simply try to understand this architecture, like how these things are going to work. Then that's it. Very easy. Right. So now here, what I'm going to do now, let me deploy or point the namespace here, or deploy a container into our default namespace. Okay. So what I will do, I will deploy a new one. kubectl run nginx. So here I am not pointing to any namespace, means it will go default to our dev-env namespace. So here you can see deployment nginx is created. Right. So kubectl get all. Right. If I see all, means whatever the components are created with the run, with the deployment, with the run. Right. We'll see that all. It created a pod Pod, right? Pod means now here you can treat it as a container. It created a pod for us, and it created a deployment also. The deployment means what is the service you want to launch inside this pod, means inside the container. That will be tell by the deployment. That will see. I will show you how to define these deployments. Then replica sets, nothing but the how many pods, how many copies you want to launch at this deployment. Here I have asked for one, I got the one. Now run the command of export. Yeah. So usually if you right in our Docker structure, right? So because the Docker only in the background, Docker containers are running. That's it. So if I want to access any services which are running inside the Docker, what we are going to do, where the Docker is installed means the Docker host system. We'll take the Docker host system IP, then followed by the port number. That's what the process we are going to do, right? Same here also. So now here where the Docker is running means this Docker is running across all the three missions, nodes and the masters. So you can take any master IP, any node IP, then you can use the port number, whatever the port you are trying to export to access the services. Right? So now here I'm going to run the command now. So it should not show any error for us. Right? So here you can see it created one more object called service. Right. So let's try to run the command get all. Now we are going to see four components, right? LA3 now, LA3, 1, 2, 3. Now you can see four. Pod, one more came into the picture called service. Right, the service is going to tell us the node port. We'll discuss more into the service and deployment. Let's try to understand right now is the node port. Then here deployment and replica sets. Extra one is service is created. Right. So now here I will go to AWS account and I will take any node IP. So let me take the master IP, copy, and here 80. I'm taking the node IP 80. See, it's not able to access the service which is running inside the container. Nothing but the pod, right? So the first troubleshoot is when you are not able to access means whether the security group is allowed or not. In the security group, the port is allowed or not. Let's go and see the first troubleshoot point. So this is the security group launch wizard 11, right? Because all together we have launched in a single shot, right? That is the reason only one security group will be allowed to, attached to all the nodes. I had given as a count 3, right? So now simply I need to change only one is fine. So we got applicable to all the three nodes. Action, region, boundaries. Here clearly showing all the ports are open. So right now this is not the issue. So now the thing is our cluster, Kubernetes cluster is going to use the port numbers 30,000 port numbers to 32,700. Kubernetes cluster is going to use the port numbers 30,000 to 32,700 ports. Okay, so any service, any deployments you are launching, those services ports will be between the 30,000 to 32,700. That is the default architecture, default structure for the Kubernetes. Right. So now here I said expose the port 80. 80 is the Nginx default port. I mentioned like the container port I asked you to expose it. So now I have not mapped it. I have not mapped the port number to means right. If you observe our Docker -p, our host port number colon the container port number, right? 81 colon 80 something like that we are given, right? So now it is going to map our container port number 80 with our host port number. Here simply I said like expose it. 80. So now here I did not mention the port means by default your cluster will be taken care of the mapping of the port number. Right. So now here I want to see which port is mapped so that I can access the service into the outer world. Right. So now here when I say kubectl get all, now it is going to show us all the objects. Right. Objects are nothing but the pod service. Right. So now to access any service which is running inside the cluster, right? So that will be accessed via service object by using service object. Remember, guys. So the service object is the one which is going to use to access the services into the outer world. Deployment object is the one which is going to use to deploy, create the pods into the container, sorry, into the cluster. So what kind of pod you want to create, those information you are going to provide in the deployment. So now here to access means we require a service. Now I have the service now which is pointed 80 to the port 31336. Right. So now this is the node port, type is node port. So now here the node port is point mapped with the port 313133 because as I mentioned the ports are going to utilize between 30,000 to 32,700. So now let's go to our browser and use the node port number 31336. See, I'm able to see the Nginx. With that. So now here this guy when I said use the node port means this guy will take care of uh, it will take care of the service accessing the service which is running in any node of the cluster, right? So the service means the application which is running inside the container, right? Whatever the app you are trying to run, right? That can be accessed by using this service port, by using this service port. What the port here? This one. Right now you may get a doubt here, right? So here the doubt can be if I say kubectl, get pods or get replica set, there I can say I said only one container I am looking for, right? So only one container means only one pod I am looking for. So that pod is running fine. So now here either the pod can be run on master node or the slave one or the slave 2, right? Either it is in master or in slave 1 or slave 2. So now you suppose let's see here what you assume. So kubectl get pods. Now you can see a pod, a container is running, right? So now here I want to see on which node this pod is running, right? So now here, right, so on which node this pod running, what is the image is running, which namespace it is using, right? If you want to see the details, which command you need to use? Describe. Any information if you want to see, either it's a pod or a deployment or service or whatever it may be, the object information, if you want to see, describe is the command. Remember it, guys. So now here kubectl describe, which you want to describe. I want to describe the pod. So describe pod, then which pod? This is the pod. Enter. So now here you can see it is going to give us complete details about the pod. So here if I want to see the node information, let's scroll up. There you can see the node information. 70. If I go to my dashboard, not the node 1, node 2, 70. Right? It is running on the node 2. So now here in our cluster, in our Kubernetes cluster, the resources, whatever the resources we are deploying, those will not be deployed on the master. those resources are not going to deploy on the master. Instead of those resources are going to deploy on the slave nodes. Means either if you have two slaves, on the two slaves the load will be distributed. If you have five on the five it will be not on the master. But if you guys observe on the Docker swarm, right, the load also going to take care by the master. Not only managing the cluster, Docker swarm, it is going to take the load. But in the Kubernetes, the master is not going to take your load, simply going to manage. Okay, so now the loads, now the nodes are going to take care of your load. Your load means what are the objects we are trying to create. That I will show you some point of time why this master is not taking the load. Okay, I will show you the reason also. So now here, so now we can leave the master. So now out of the two nodes, one node is taking the load. But here, if I use my master IP or if I use the node one IP, still I can access. Right, that's what here your Kubernetes. Kubernetes will be take care of the cluster. Now inside the cluster is either 100 nodes are running, 1000 nodes are running, but outside is like a single node, a single thing for us, a one entity for us. You can access it, right? But in the background means what's happening here is it is working as a load balancer. Simple, right? So now here the load balancer is a concept of when the people are trying to hit the applications, now the load balancer will take the load and it will be distribute the load into the nodes. Now same thing is happening here, right? So we'll see. We'll see the how this node port is working. The reasons I will explain in our next session. Not next session means in the next slides. Like so now here try to understand. So now the node port is a one which is going to use to access the service outside of the cluster. Right. So now if you want to use the node port, now this is the process. Expose or let me go to here. Expose here at the time you need to tell them type what is the type here. Okay, so now here now until now we have seen with the commands with the CLI I am trying to create the containers. I am trying to what's called if I want to delete the containers, I want to expose it means like adding the service to the pods, everything with the CLI. Right. So now how to see the CLI information, how to get the help if I'm not understanding about the particular command, right? So here I'm trying to run kubectl get, describe, delete, pods, deployments, something like that, right? So now how I'm going to get the help? The one is Google. Always Google is there. Go to the Google, then try to run the command, like try to give the command to the Google so that it will give you the more context. Or the second one is with the CLI, if you want to see the help, kubectl, right? Just try to run kubectl, enter. Now here you can see there are bunch of commands it's going to show us here. Create, export. We have seen the run, correct? We have seen the you use the run and explain documentation of the resources. This is what we need to see. Help and get, display, edit. Right? You can see some commands here: rollout, scale, auto scale, something like that. Suppose I want to see right the run, how to use the run. Then what I'm going to use kubectl, right? Here it is going to show us kubectl command help, kubectl and run, then hyphen help. I want to see the run command, how to use the run command. Create and run particular right. So container. So here you can see create and run a particular image, right? Pod means it's a container. If I want to create a container, what is required for me? The input is image. It required a image. So now here what the run will do, like a Docker container only, Docker run. It will create a pod with the help of image. Now creates a deployment, right? We have seen the deployment information. Our job to manage the created containers. So now here, how to use it? This is what we have taken, right? So now here you can use the other options like port exposing. You can use the environment passing, You can use the label, something like you can see the example here. Like if I want to create 5 pods, 5 containers, like that you can see the help, see the mind. So now here, one second guys. Now here we can see the help. We can get the help by using the CLI, nothing but kubectl, the command and the help. So now here, if I want to see the documentation, kubectl. If you want to see the documentation you can get with the help of explain. kubectl explain pod. Right. So now here you can see the pod documentation. Right. What the documentation means? If I want to create a pod, what are the properties I need to use? Right. So if I want to create a pod, what are the properties I need to use? And the properties explanation. Right. So if you want to see the pod, if you want to create the pod, there you need to use the kind as a pod and version you need to use as a v1. I will show you where we are going to use. Then here the description, what exactly this pod is. Pod is a collection of containers. As I said, you can launch multiple containers in a pod also, right? So now here the fields, the properties. These properties we are going to use to create a pod. Metadata, specifications, status, something like that. Right. So this is the documentation you can get with the help of explain. And if you want to see the examples to run these commands with the help of help. Right. So now here with the right. So now as of now, we have seen kubectl get rs. We have seen as of now creating a container, nothing but the creating a pod with a copy of only one. Now I want to replicate it. I want to have multiple copies. Right. So if you want to have multiple copies, then what I need to do, I need to scale up the pods so that it is going to launch multiple replicas of your containers, of your pods. Right. So how to scale up the pods in the cluster? Right. So now here again I will go to the kubectl. Now here in this commands, I am going to take the command called scale, deploy commands. Scale. Scale a new size for your deployment, replica sets, replica controls or jobs, replica sets. So now here I want to scale. What do you want to scale? My pod or my deployment called Nginx. I want to scale it. So let's take the help here, kubectl scale hyphen help. Right. So now here kubectl scale replicas. How many replicas you want to? These are the objects. RS means replica set. Hyphen F. I will show you. This is YAML file, and this is deployment. And these are the different replica controllers, RCs. This is one for one replica controller. This is a separate replica, and this is separate. Like multiple replicas also, you can take it. Multiple controllers, right? So now with the name, if you want to replicate with the name, stateful set name, like that, like the multiple examples. So now here, I am going to take this command or we can take this one also. Anything is fine. Here is going to tell us my current replicas are 2 and I want to have 3. This is going to tell us I want straight away 3 replicas. RS FOO means FO is object name and RS means replica set. So now here I will let me take this one and kubectl get RS. I will get the my replica set name. This is our replica set name. Now here let me take this command. So now here I am going to use RS slash my replica set name. So now here I'm going to tell I want 3 replicas. Now you can see scaled out. Now kubectl get RS command is not it is not applied on this one. This is not applied on this one. Let me take the command. So it is not taking that replica, so it's not able to understand our replica name. Let me do something like this. Insert. We can use something like this also. RS scaled up. Okay. So maybe with the default Nginx, it is not able to take. Let's take in the other way. The other way is kubectl get all. Okay, maybe this one we need to provide replica set. Yeah. Okay, let's try this one. Insert. Let's see now here. Scale. Now kubectl get RS. So yeah, it is not taking this replica set name. So I'm going to take deployment. Right? We can replica either with the RS or with the deployment also. Right? So let me take this command now and see, because the replica is not taking here for this Nginx. So what I'm going to do, I'm going to take my deployment Nginx. So here I am going to use deployment slash Nginx, and here I'm going to tell current replicas are 1 and I want to have 3 replicas. kubectl get RS. Right. So yeah, so replica set is not taking here somewhat the Nginx because of the default thing I know. So I know in the sense we are not sure, but anyway the deployment works for sure. So here I have taken the deployment Nginx. Our deployment name is Nginx. That at present 1 by 1 is running. Now here I ask for the replicas of 3. So when I say the 3, desired 3, current 3, and ready 3. Right. So kubectl get all. Now you can see the deployment is scaled up. It is also showing a 3 3. Right. Now kubectl get pods. Now you can see here 3 pods are going to run. Right, 3 containers. Earlier it was only 1. Now it become 3. On which nodes these containers are running? Now here I want to see on which node these containers are running. The one way which we know very well is with the help of describe. kubectl describe pod name, so that it will provide you the complete information. There you can find the node information where this pod is running, on which node this pod is running. Now the other way is kubectl get pods -o wide. -o wide is an option. It will give you more information about these pods. If normally if I use get pods, it will give us only name, ready state, status, restarts. Any restarts are there, and yes. Now here, apart from that, it's going to give us IP. IP means this Nginx IP, the pod IP, right? So pod means each pod is a server, a lightweight server. So each server will be having their own IPs. That's what here. And this is the node on which node these pods are running. Right. So now on 17, two contents are running. On the other node, 182, one pod is running. Likewise, you can see the pod informations, right? The pod informations along with the node information by using -o wide. Right. Likewise, we have multiple ways are there. Like multiple ways are there to see the pods information. The other way is describe pods. Then you can search for, right. So now here kubectl describe pods. So what will happen here? Whatever the pods are running in the namespace, right now three pods are running. All the three pods information we are going to see here. All the three pods information. Right. So now here, if I scroll up somewhat here, there you can see the node information also, right? We have seen that one also. Scroll up node. Right. So now what I'm going to do from this complete content from this page, I want to see only the node, right? Because I want to see where this pod is running. Now here we have options, multiple ways. One is go to the describe and see something like that. The second way is simply -o wide. Now the third way is kubectl describe pods. Then just grep it. Grep for the word called node. That's it. Kubectl describe pods. Then pipe symbol, right? The line X pipe symbol is a combination of multiple commands. Now here grep for what? For node. Right? 17 on 17 two pods are running and 182 one pod. Like that. Like in multiple ways you can see it. Okay. Right. So now here I know, right? We know like what are the nodes are being used by to run these pods. Right. So until now we have created the pods, scaled up the pods, did the pods, everything through the CLI command line interface. But in the real time, we are not going to do something like that because, right? So your applications, this is Nginx, which is a default one, is available as an image, right? In our Docker Hub, you can get these images. But for the real time, we are going to create our own images, right? Based on the project, whatever the project we are working on that. For that project, we are going to create the own Docker images. Now the Docker images will be running as a pod inside in our Kubernetes cluster. Now you need to deploy your custom images as a pods, not the default one. So for that, you cannot run the command something like that. It should be a continuous integration, continuous deployment model, not like manual model, right? So your Jenkins has to be taken care of the object CA process, and your Jenkins has to take care of the deployment process with the help of Kubernetes. Like that, automatically it has to be happen, right? So for that, what we need, right? For that, we need a deployment process. We need a deployment process. What deployment process you need? To deploy my containers, nothing but the parts, or to deploy my services to access into the outer world, right? Service means no node port. Node port we are going to use, we have used to access the service. Likewise, the objects creation going forward, we need a process, not like the CLI, like how I did right now. So now the process we are going to call as a manifest files. In our Kubernetes, we are going to call this process as a nothing but the manifest files. With the help of the files, we are going to deploy the objects. What objects? Pods, service, deployment, replica set, like this. Let's kubectl get all. Right, whatever the objects are created here, right? So pod, 3 pods, service, deployment, replica set, right? All we are going to create with the help of the files. Those files we are going to call as a manifest files. Now these files are going to fed to our Jenkins. Right? So now Jenkins will consume these files and it will create a objects for us inside the Kubernetes cluster. That's what your CI/CD process. Simple. Right. So now here how to create, how to use the files to deploy these objects. Right. How the files are going to use. Right. Let's see. Now here I am going to convert these commands into the files, and with the help of the files we are going to deploy the objects again. Right. Let's see now. So here we have different objects. Different objects are nothing but pod is an object, replica set is an object. Replica set means replica controller we are going to call. Deployment is an object. Service is an object. Right. So now these are like many objects are there in the Kubernetes. So these objects now we are going to create with the help of the files. Right. So now here if you want to create only the pod. Right. So if you want to create only the pod, then here you can say this is the manifest file. If you want to create only the pod. So now here let me take the file. Now I am going to create a pod.yaml file. Right. So now here API version. Right. So in our deployment files, we need to mention which version of the API we are going to use. Right. So now here the API version means in the architecture, if you remember the architecture, every command either with the CLI or with the GA in the cluster, the first component will be the API server. Right. So your API server will be taken care of your inputs. Like your input can be UA input or the CLI input. Then the API server will be sent to the our controller schedulers or etc for the respective object to be created. Right. So now here, which API server we are going to use, which API server we are going to use to accept to work with the pod. So that's what here we are going to tell API server version is V1. Right. So now here, why the V1? Now if you know, if I in the help I have shown you, right, kubectl explain the documentation. In the documentation, they clearly mention like use the API version V1 for the pod. Okay, I will show you one more time also. So now here, what is a kind? Kind means which type of object you want to create. Right. So now here, as I said, different objects can be created out of the objects. I want to create a pod object. So that now how this manifest file will tell your cluster. That's what the kind. So now we have seen the properties, metadata, specifications. Metadata is nothing but this pod identification. Right. So now how we are going to identify the pod? You means your cluster. So now your my cluster will be identified this pod as a sample pod with the name sample pod. Now this sample pod can have the label set with the labels called like my sample pod will be running in the zone pod, production, and with the version. Like you can what is called, you can divide it. So that when you want to fetch only the version one with the help of this attribute, you can fetch only the version one pods like that. Easy identification. Right. So metadata is nothing but the pod identification. In the pod identification, you can provide only the name, or you can split into the pods so that when you want to fetch the information, simply can use these labels. So I want to get only the production running pods. Now I'm going to use zone as a pod production like that. So now here, once the identification information is provided, then the specific spec means what is the pod you want to create, and pod means a container. For the container, which image you are going to pass as input, like that. So now here, my specification nothing but I want to create the containers. Now this is my name of the container, and this is the image input.
Yes, sure.
Right. So now here, right, the container port. If you are not passing the port means you cannot expose into the outer world, right? So this is the port I'm going to use. So now into the outer world, you can use. It is going to use the cluster port 30,000 to 37,000, right? So likewise, this information which we are going to provide in the YAML file to create this part. How to know, how to understand these properties, right? So for that, the help kubectl explain part metadata specifications. Right? These are the these two properties. Apart from that, you can see let's kind API version. Right? This property, these four we have used, and also we have one more property status also. Right? So here the API version. API version define the version schema of this representation of an object. Right? So kind, what kind of object you want to create, the object represents. And here you can see kind as a pod, version as a v1. Right? If you want to see the complete API version details, right? Because the API is the one which is going to take your arguments, your inputs. Right? So if you want to see the complete API informations, right, that is also you can find it. If you want to understand more on this kubectl API versions, print the support API version on the server. Right? So kubectl these many API versions are going to support on your cluster. Admission, registration, API extensions. Now here apps v1, apps v1 beta 1, beta 2, batch. These are the auto scale versions, and these are the RBAC authentications, certificates, events, like that. The version supports what are the versions are going to support v1. This is the one we are using right now, v1 version support. Likewise, if you want to know the resources, right, what are the resources are going to support here, API resources. So kubectl API right. So here you can see namespace binding. Any short names? No. Namespace is required or not? Required. Right. So here nodes, short name no. For the nodes, namespace is required? No, because nodes are running in a cluster. Inside the cluster, the namespace are going to create. False. Pods. Right. The pods shortcut name. You can use the PODS pods, kubectl get pods or kubectl get PO. PO is a shortcut name. So true, namespace is required. If you want to deploy the pod, the namespace is required. So likewise, the resources services that require the namespace. The shortcut is SVC. Like that, you can see all the resources of the Kubernetes cluster here, like that. Right, like that, like this. This is a like with the help of this kubectl, you can get more information. You can know more information about your resources and replacing the commands and other things. Right. So now here ls. Now I have a pods.yaml file. Now this pod.yaml file I have told like version one I'm going to use, and this is my pod, and this is my sample data, and sorry, this is my metadata, and this is my spec. Now I want to create the container, nothing but the pod inside the cluster. Right. If you want to create the pod, right, earlier we have used the command called kubectl run. Now here I am not going to use any run commands because I am going to use the manifest files, deployment files. So now with the help of the files, I want to create it. Right. So now here again, kubectl. Basic command, create a resource from a file. Kubectl create --help. JSON and YAML formats are accepted. Right? If you want to create any resources, any objects inside the cluster, either you can use the YAML formats or the JSON formats. Right. So now create a pod using the data in a pod.json. Suppose I'm using the JSON, then create -f is the command. -f dot means current location. From the current location, pick the pod.json file like that. And this is one more by using stdin, standard input base, cat pod.json, and this file I'm going to pass as input to my kubectl create command. And this is one more way. So edit the data, right? So here once you created a file, then you can edit, that means you can edit the file while creating it. Create -f, then edit the file and create the resource. Likewise, the create command can be used to deploy your objects into the cluster with the help of the files. Okay. So now here kubectl create -f, then my file name is pod.yaml file. That's it. So with the help of this file, I'm going to utilize, I'm going to use this pod.yaml file to create the pod inside the cluster. Kubectl get pods to see the running pods information. Now here you can see there are 3 pods are running. Those are from my Nginx. Right. Now you can think something like that, microservices. Right. So in the cluster, the basic purpose of the cluster is to manage your microservices. So now you can have 5 microservices, 1 microservice, or 10 microservices, or 100 microservices. You are part of the application. Now you have to deploy all the services into the cluster. Like how? Like this. Like now this is one service and this is the second service. Like that, n number of services can be deployed in the cluster. Now now you are going to call one service to another service. They have to interlink one each other. That's it. At the end, it is an application. But in the back end, there are the individual services running in the cluster as a containers. So now here, sample pod is the one, right? So ready state here, it is not at ready, right? So why? The status is showing as a image pull backup. Image pull, right? The word itself is telling us image pull. From where the image has to be pulled? From the hub. From the hub, right? So now from the hub, we are telling like pull the image. So now here it is not able to pull the image. That's called the image pull backup. Now if you want to see more information, right? kubectl describe pods. Then my pod name is sample pod. From where we got the information? From the deployment file, right? In the deployment file, I have mentioned my pod name will be sample pod. Sample pod. Right? This right metadata identification. So that name it got picked and it is displayed here. So now kubectl display pod sample pod. kubectl describe spellings are wrong. Describe right. So here it will show you more information about the status, right? So default successfully assigned this one, After that, it is trying to pull the image from the so and so DevOps trainer and Ubuntu sample and fail to pull the image because this DevOps trainer repository is not able to find inside the hub. Our documents it is someone private image, some XYZ person private image. So that is the reason I am not able to pull it out. So now what I am going to do here is it is going to suggest us if it is a private repository, then try to log in. You may require the login. Right now we know right so how to log in the repository Docker login, then forward the username password so that it will connect to your private repository. It is a private one. So I have used someone's repository. There is a reason it is not able to pull, but even I don't know the authentication details of this private repository. So what I will do, I am going to provide the public one, nothing but the Docker hub. Instead of going this one, let's take our here I am going to use our Nginx. Syntaxes are very, very important. Please take care of the syntaxes. To move left side or right side, it will throw in errors actually. Okay. Save it. Right, so now here again I'm trying to run the command. Right, so here already I have created. Right, already we have created, it is throwing some error. So now again you are not going to require the create option here, the create command. Right. First time the create, next time onwards update. Update means here apply. Right. So now here I'm updated my file, pod.yaml file. Now here next time onwards I'm going to use apply. First time will be the create, and the next time onwards you need to use apply. Or straight away you can forget the create option, create command. Simply you can go with the apply. If you are confusing with the create and apply, then just blindly go with the apply. So even it will take care of the creation also, even though it is the first time. Right. So now here you can see here pod sample configured. Right. Already is there. It is updated. So now here kubectl get pods. Now we can see it is running. Right. So earlier it was a private repository. That is the reason it is not able to pick it up. Now I have given the public one, Nginx. It is running now. Right. So now here likewise, if you want to create a pod inside the cluster, right? One is with the CLI, like how we created. The second one is with the manifest files. So now in our real time, we are going to use the manifest files. We are going to create the deployment files. We are going to call it the manifest files or deployment files, whatever it may be. The technical term is manifest files. So we are going to create the manifest files, and with the help of the files, you are going to create the resources based on your CI/CD process. That's it. Okay, we'll see that one also at the end. So now here I have created a pod, but here in the real time nowadays, now the pods are not being utilized. As I said, you are going to have only one container in the pod, even though it can maintain multiple pods, multiple containers in the pod. But the thing is, you cannot use the same port for the same containers inside a pod, right? Because they are going to use only the same network of the pod. In the same network, you cannot use the multiple ports, right? The port conflict you are going to see. You are going to face if you are trying to use the same ports inside a pod. So that is the reason always the best practice what we are following here is one container we are going to run in a pod, so that n number of pods can be created with the same port, so that I can utilize the same service the same port. Otherwise it's a bit complicated for us. So now here, now here if I want to deploy my service, the one way is pods. Now the pods are not the suggestible way for the deployment. So now then what? Which one I need to use? If the pod is not the searchable one, then which one I need to use? So for that, we have an object called deployment. Right, guys, here I have explained it. and sorry, here explained it, and you can see the examples also how to expose, like expose command. Already we have discussed about this one. So then create -f, you can see something like that, right? So now here the parts are the not searchable one. Now the searchable process is the use the deployment object instead of the parts. What is an advantage here, right? If I go with the deployment object instead of the part, then what is an advantage here? The advantage is you can create the replicas. By default the pod is not going to support the replicas of a containers, nothing but the parts, right? Usually for high availability we are going to have minimum 2 replicas, right? So that if one pod is terminated or is dead with some other reason, still you can have one more pod to give the high availability for the customers. Otherwise, if I have only one pod, even though I have one pod, your application will be running always up and running, but the high availability you are going to lose, right? So how I am going to lose? Simple, right? So if I go here, kubectl get pods, but already, yes, already here we are, right? So now here I have a sample pod. So if some reason kubectl delete pod, I'm going to delete the pod. Which pod I want to delete? Sample pod. Right. So now here the deletion is going to progress. So now when the pod is deleted, by the time we are trying to hit the request to this pod, they cannot access because the pod is being deleted. It can be 5 seconds or 10 seconds or 1 minute based on the server configuration, based on the networking, everything, based on the other circumstances. It can be a one mission. It can the delay can be a 1 second delay or 5 second delay or 10 seconds delay. We don't know, but yes, we are going to see the delay. The response will be delayed because the pod got deleted right now. So until the new pod came into the cluster. So right. So at the moment it got deleted, at that moment if someone is trying to access the service, they are not able to access because the part got deleted. So now here again it came back. It not came back, huh? Okay, maybe it got deleted. Even is not back. Okay. Right. So kubectl get rs. Right. So right. So here, yeah, I will explain why it is not came back. Okay. Now here let me try to delete this one. Kubectl delete pod. Now 5D got deleted. kubectl get pods. Right, you can see 4x, G6M, 8F is there. Now 5D got deleted because I asked you to delete. Now one more came back. Right, here it came back, the third one, but when the sample pod, it is not back. Right, we'll discuss about the reason. Right, so now here the thing is high availability. Right, so here immediately the pod got deleted when I deleted the pod. Sorry, immediately the pod created when I did the pod, but there you can see some delay, 1 second delay or 5 seconds delay between the termination and new creation. By that time if the people are trying to hit the service, they are going to see the delay, the response delay, right? So that's what not the high availability. We are not going to target the high availability. High availability means even 1 second also your application should not be down. That's for the high availability. So now to maintain the high availability, who will take care here? Our replica sets. Our replica sets are taken care. Right. So in the replica set, I am going to tell I want 2, I want 10, I want 100. Right. So now in the replica set, when I said the replica set 10 means now the controller will take care of the desired and correct. That is the background story. Right. Now how I am going to provide the replica set information, like you want to 2, 10 or 100. Right. That is one, the scale command. Right. With the scale you can mention, like that's what the CLA process. Now the second way is deployment. it can create the replica set. But in the pods, if you guys observe here, in the pods, in the pod object, parts in the pod object, I don't have any kind of spec called replicas. It is not going to support the replica property. So that is one. That is this is one backdrop for the pod object, right? So likewise, if I use the deployment, I can have the option called replicas. I can create the number of replicas and scale up also easy, right? So now here the scale up. If you try to understand the command scale, the scale command can be utilized on the replica set. The scale command can be utilized on the deployment, but not on the pods. Scale up can be easy, right? We have used the deployment only. Cube scale. My initial replicas are 1. I want to have 3. Then deployment slash nginx. Deployment. I have given the deployment name, deployment object, right? The scale up can be easy. Exposing to the outer world, right? Even to expose, we have mentioned the deployment only. Expose deployment nginx, right? So with the help of the deployment, you can expose that into the outer world easily. Rolling, very important feature. Rolling updates and rolling backs are more efficient, right? When the new version came into the particular product, that can be easily update. The rolling updates can be easily done. If something is failed, easily it can be reverted. I will show you how to roll up and how to roll back, right? So now the deployment will be having multiple features than your pod. So that is the reason in our real time we are not going to use any pod deployment files. We are going to use the deployment file, deployment manifest file, because it is a pack. It is a pack of with features called. You can create the replicas, you can scale up, you can roll back, and you can roll up that. You can expose easily. Right. So now here I want to have my deployment file. Before going to the deployment file, let's understand this problem. The problem is when I created a pod, right? When I created a pod, I can see the pod got created. But when I delete the pod, I am not able to see the pod is back. It's gone. Why? Why means I am not mentioned anywhere the replica set information. If in the replica set information, if I provided I need 1 or I need 2 or I need 5, now the replica with the help of control manager, it will be taken care of minimum parts, desired parts and current parts. Right. So now here the pod is not having that kind of feature. So that is the reason just it created the pod. When I did it, it is gone. Right. It is not linked with the control manager. Right. So means it is not, it just created the pod object only. It is not created any replica set. Any replica set, and it is not created any deployment. So when you don't have any replica set, you cannot manage the desired state. That's where the pod got deleted and it is not created back. It is not come back because it's not having the replica set feature. Simple. Replica controller, right? Replica set is nothing but replica controller. Control means again control manager, like that. So now let's go to the deployment object now. So now here I am going to use right. So now the deployment supported version is extension v1 beta 1. v1 is the version which we have used in the pod. Now the v1 version is not supporting the deployment. So the deployment support version is extension v1 beta 1. We can observe this thing in our API version and API resources at the help. You can go to the help and there you can find this information. So now here, kind means with what kind of object you want to create. I want to create the object called deployment. Like earlier, we use the pod. Now the deployment object I'm going to tell to my API, so that is going to create a deployment object for me. So now here, the metadata deployment identification, I have provided a sample deploy, some name. Now the spec, right? The properties. Now in the spec, as I said, the deployment has a feature of replicas. You can deploy, you can have the replicas of your deployment object. How many you want? I want 5. Right. So now here, now this spec templates, again, the specification, nothing but is going to create a container for us. So now to identify the containers, now this is the metadata, the containers information. Right. So now here the template, in the template we are going to have the metadata. So now the metadata is nothing but whatever the containers I'm going to create, it will be identified with the name called sample container. The labels I mentioned as app. My app name is sample container. Right. So this metadata about the containers and this metadata about the deployment. So now here, right. So now here the specifications will be having a template. Now this template will be having the metadata and again spec. Right. So now this specification is nothing but the deployment specification, and this spec is nothing but your container specifications. So now here I want to create a container. What is the container you want to create? With the name sample pod, and the input is nginx, and the default port of the nginx 80. That's it. Right. So now it's going to create five containers for us, because I have mentioned five. Right. So now it's going to create a deployment object for us, because it's a deployment object. Now what the deployment will do right now, it's going to create a five container, means it's going to create a five parts for us. Apart from the parts, it's going to create a replica controller for us, five replica controller, replica set, and apart from that, it's going to create a deployment object for us. The three objects are going to create now: deployment object, replica set, and the third one is what is the third one? I forgot it. Replica set, deployment object, and the parts. The containers means the parts. Three objects are going to create. Now save it. kubectl. First time, right? You can use the create, or you can forget about the create. Simply can use apply. Even this is the first time or second time or n number of times. kubectl apply hyphen f. You can use dot, take from the current location, but there are two files are there. One pod file details, and one is the deployment details. It's going to take both. Now I don't want to have the both, so that you can use the file name deploy.yaml file. Right, so now kubectl get all. I want to see all the objects information. Right. So as I said, five parts are created. 1, 2, 3, 4, 5. The parts are identified with the sample deploy. These are the unique identification numbers. And here service. This service is not for ours. This is for the nginx which we have deployed earlier for this one. This is not for us. So now here you can see deployment, sample deployment for 5, and one replica set for the sample deploy. As I said, right? I said with the deployment manifest file, three objects are created. One is the pod, and the second one is the deployment, and the third one is the replica set. Now, if you are trying to delete any deployments, nothing but the parts, it will create the parts back, because it is having the replica controller. Like as I said, I want minimum 5. If less than 5, immediately you have to create the you have to match with the 5 immediately, right? So that's what is going to happen. But in the parts, we don't have the such feature. When I delete, it's going because it is not having the replica controller. That's it, right? So likewise, so now here I have created the pods, the containers, with the help of deployment manifest file. Now can I access these services into the outer world? No, because I have not mapped the service object to my pods. Now you need to understand like this, right? The containers, the services can be launched with the help of deployment object, but you cannot access the services into the outer world until unless you mapped with the service object, right? Service object is the mandatory one to access your services into the outer world. So now these parts, now at this situation, at this moment, I cannot access these services into the outer world because the service is not mapped, right? So now here what the service is here. Now the service is going to play a vital role in the cluster, nothing but it will be played as a role of load balancer. It's going to play as a role of load balancer. So now here whatever the request will be sent via the API server, it will go to the service object. Now from the service object, the request will pass it to the pods. Now from that it will be sent back. Right. So now here that is the reason in our starting of the class, even though I have deployed only one replica, only one copy in the cluster, there are 3 nodes cluster. Forget about the master, there are 2 nodes are there, but still I can access with any node means the service will be taken care of accessing the service into the outer world. The service is going to take care of the accessing the service into the outer world. Right. So now here same load balancer concept here. So here this is my cluster and here this is my service object. Now here whatever the pods you have created, nothing but the your containers, maybe there are 3 or 5 or 4 or 10. These will be connected to the service object. Right. Now I said I want 5 replicas. Now all the 5 replicas are need to be connected to the service so that the request which are coming from the outer world will go to the service. Now from that it will be distributed, it will be sent to the your pods. Right. So now here the service is the object which we want in the service. We have one type called node port. In the service we have multiple types to access the outer world, to access the service in the outer world. Out of multiple, the one is the node port we have seen. So now here the service type is a node port. So now the node port will be using the 32 to 32,700 with with the particular port, right? One particular port will be allocated to all. So now here in our earlier case, it allocated some port called 31336. This is common to everyone. Common to everyone. Yeah, so this is like the service will be used to handle the load which is coming from the outside to send to your servers. Your servers are nothing but the parts. The parts are nothing but the containers. Now the service will be having a one unique IP. I think we have deleted a node port. Yes, the cluster IP. One IP it is going to have. Right. So now this is the one port which is going to allocate. It is going to allocate to all the containers which are running in the different nodes. Right. So what the service object here is, the service object will be used for to access your services into the outer world, and the service will be act as a load balancer. So it will be having a unique IP, and the service will be having different types of methods to access the service into the outer world. Right. We'll see. I will show you what are the different methods. Right. And in out of the different methods, the one type is the node port. Right. So let's go and try to see on the slide side so that I want to access into the outer world. So now here this has happened, this is completed, and our 5 parts or whatever the set I have given the desired and current and up to date we have seen with the deployment. So now here we'll talk about the service object. To access the application which are running in the parts, we need to have a permanent IP. So service object will be take care of it. Right. So right at the end, we are going to use one common thing for us, one common thing for the ports. The common thing is the permanent IP. Permanent IP will be allocated by the service. That is the default in the background. Your Kubernetes will be taken care. We don't require to provide or map or anything to the service object. We don't require. That just will tell what type of method you are going to use. Right. So now here all the parts or replications will be having the same labels. Right. So now here how the service object is going to understand, okay, these parts are belongs to so and so, these parts are belonging to so and so. Right. So now here you can see here there are different set of kubectl get all. Now you can see there are different services running here. One is Nginx, different deployments. One is Nginx and second one is sample deploy. Now for the sample deploy, 5 copies are running. For the Nginx, 3 copies are running. So now here, if Shankar wants to hit the Nginx, right? If Rajesh wants to hit the sample deploy, right? Your request, right? The request has to be like it. My Shankar request has to go to the Nginx, and the Rajesh request has to go to the sample deploy. So who is going to take care? The service object is going to take care. So now here I have total 8 pods are running, right? So total 8 pods are running. So now when the request is coming to the service object, the load balancer here, right? So now here, now the Rajesh request is going to the service object. Then from that it has to go to the 5 parts, sample parts, only the 5 parts, not to the 3 parts, because his request is to the sample parts. So now how this service will group these 5 parts as a separate entity, and how this service is going to group these 3 parts as a separate entity. Then when based on the request, it will send to the that particular entities. Right. So that's what the labels. So now when you are trying to create any objects, any object, we are passing the label names. Cat deploy. Very, very important. Right. So now here, when I'm trying to create my sample deployment object, now the deployment object is looking for 5 replicas for what? For my Nginx. Right. So now all the Nginx containers, all the Nginx containers are labeled with sample container. This is the app name. Right. So now here, this app name, nothing but the label, I am going to attach to my service object, so that whatever the containers, nothing but the parts are having the sample container, those will be grouped together as a separate entity. So whatever the other service like the Nginx will be having the label name some XYZ, those XYZ will be grouped together, so that the service, the traffic will be routed to the particular objects like that. Right. So now here, that is one thing. The in the service object, all the parts are replications, so all will be having the same labels. So with the labels, the name parts will be attached to the service object. Right. So now here, because your cluster always will be checked with the checking, we always going to check the health state of the nodes. Now based on the health state of the nodes, it is going to move the load. Right. Suppose on a node 1, the load becomes 80%, but on the node 2, the load is very, very less, like 20%. So now this cluster is going to take care of the load distribution, so that both will be having a equal load. Somewhere in the background, you are not going to take care anything here, right? It will going to it is going to manage in the background by a cluster, right? So when the load is moving from one node to another node, from one area to another area, now here when the right load means the parts, the running containers, the running parts are going to move from one node to second node to third node, like that. So when the containers are moving from one node to another node, so how they are, those guys are grouping together again, right? So how the right again, right? So here total I have 8 parts. Suppose total 5 parts. These 3 parts are sample deploy, and the 2 parts are my what is called Nginx. So now here, suppose right now assume this one node and one node. These 5 means the 5 parts are deployed on the one node. So now these are the one group, and these are the second group. So how this service object will identify with the label names. Now here I am going to my cluster. Later on, my cluster is moved 2 parts from here. Right, this is my second node. Suppose this is my first node and this is my second node. Then here these 2 parts are moved from here to there, because to maintain the equal load between the nodes. Right. So when the 2 parts are moved from here, right. So now here your cluster, your service object has to identify either this pod is belongs to this particular group or this particular group. How is it going to identify? With the help of label names. Now it will check the label names. Okay, label name is sample deploy. Okay, let's bring it together here. Let's bring it together. Now it is a group for the service object, right, with the label name. Like that, this service object will use this label name to identify the parts, even though the parts are running in separate nodes. Then also, right, if you are launching, right, so now later on, later on my load is keep increasing on this particular application is mainly focusing on this particular service. Means people are trying to access this particular service. Now the 3 parts are not sufficient to handle the load. I want to have 10 parts to handle the load. Now I'm going to increase 7 more parts. I'm going to add 7 more parts to handle the load, right? So when the new parts are coming into the cluster, now how the service object again is going to group together with the label names, with the help of the label names, right? So like the label names are going to play a vital role here to manage the containers, the service, the parts in the group with the help of service object, right? So now here, how to deploy the service, right? Now the main focus of the service object is to access the services into the outer world. Now the service object will play a load balancer role inside the cluster. Now the service object will take care of the containers as a group with the help of label names, right? So now here I'm going to create a service object. Copy and VI VA service dot YAML, right? So now here again V1 API version for the service object is a V1 and the object type is service. Like we have seen the pod, we have seen the deployment, now we are seeing the service. Now this is my service name, right? This is the label name, right? So nothing but this service name app, I'm going to use a sample container. This service name as a sample as right? Like to identify, as I said, the labels are going to use to fetch the information, about the services. Now I can use the app name. This is for identification. And here the spec. Basically, the service object will play a role of load balancer, right? So that it can map all the containers as a group, and the group can be utilized to send the traffic with the help of the service object. So how the service object will be utilized means with the help of the types, the methods to access the service in the outer world, right? So now here how we are going to pass the information, the service object, the access information, the load balancing information, and other stuff. Right? That's for the spec. So now here, type I am going to use the node port. Right. So as I said, the service object will be used different methods to access the applications running into the outer world. Right. So now here, out of the different types, the one is the node port. We have seen this one only. Now I am going to pass this one only. Node port. Now here, this is the port of default for what? Your container, the deployment object default port 80, right? I have passed it as 80 in my deployment object. 80. So now this port 80, I want to map with the 30,005. As I said, your cluster will be using the port series from the 30,000 to 32,700. You have to pass the port number between from 30,000 to 32,700. So here I am giving a static port 30,005. If you observe in our previous case, I have not mentioned any port number. Simply I have mentioned like type is node port. Automatically it allocated a port number for us 31336. So now here I want to have my own port, my static port. That can be possible here like this. TCP protocol, like what kind of protocol you are going to use. Basically TCP is the default one. You can ignore this one also. So now this is the main part. Right. So which parts, which deployments you want to group together? Right. For the sample SVC, I want to group the sample containers. Right. Right. What the sample containers here? In the deployment I have mentioned, I want to create the containers with the name sample container. Means this guy. This Nginx, whatever the Nginx parts are running with the label name sample containers, those will be mapped to this particular service. What is the service here? Sample SVC. Now the sample SVC play as a load balancer. Now it will take the all the containers whose label name is sample container, that will be grouped together. Now on top of the group, the sample SVC service will be placed like this. Now this will be grouped and this will be controlled with the load balancer, another service called sample SVC, like that. Like that, labels are playing playing the vital role here. Okay. So let's take this one, copy, and okay, I think we have pasted it. Save this one. Let's create the service kubectl apply -af service. Now the service object is created. Right now, kubectl get all. Now we are going to see 4 objects for our deployment. Kubectl get all. First object is the parts. Now second object you can see sample SCC. Just now we have created. What are the type? Node port. And this is the IP for this particular service. Right? One common IP. And the port, right? I have mentioned particularly I want this port. That port is mapped. Now this is my deployment and this is my replica set. Right. So it means minimum to work with any service inside the cluster, you require minimum 4 objects. One is the pod, second one is service, third one is deployment, and fourth one is the replica set. That's it. Right, so now I can access it with the help of 33005. Now here instead of 31336, I'm going to use 3005. Yes, you can say welcome to Nginx, which is running on the port 3005. Right. So likewise, the service object is going to play a role of load balancer and is going to play a role of the exposing the service in the outer one. Right. We have seen both the CLI ways and both the manifest files ways. The manifest files is the one which are going to be in the real time. Okay. We'll see it with the project also. Right. So now here, right. So this part you can skip it, creating a firewall rule to access the port. But already we have exposed that. We have given the means we have allowed the port in the security group. This process is for the GKE, Google Kubernets engine. So there we need to provide something like that. This firewall rule can be ignored based. Okay. So now here service object types. Rolling updates we'll see later. Before that we'll see the service object types actually. Okay. Right. So here the service object will be having different types of methods to access the services, nothing but the applications which are running inside the container. Different types are there. Right. So let's see what are the different types here. This one, service types, 26 slide. So there you can see we have different types of services are available to access your service in the outer one. Right. The one is cluster IP. Cluster IP is the service. Okay. Right. So now the cluster IP is the service which is a default service. Default service type. Right. So now the cluster IP is the default service type which will be running inside the cluster if you are not mentioning any service type. Okay, right. So what happened here? So what will happen here if you don't mention any service type, by default it's going to take the cluster IP. So here the thing is, if the services are mapped with the cluster IP, those services you cannot access into the outer world. Simple. The cluster IPs are private. The cluster IPs are the internal IPs. Storing this value makes the service only reachable from within the cluster. Right. So so means the services can communicate one and each other inside the cluster. Right. Suppose if I if I deployed two services, like this is my Nginx and this is my sample deploy, like whatever I have deployed right now. So if I don't mention, like if I mention the service default cluster IP service type, then what will happen? These services we cannot access from the outer world. I cannot access. But these services can talk one each other internally. Internally, these both can talk, but externally we cannot. When if the services are mapped with cluster IP. Cluster IP. Like that. So like when you want to have the only internal communication between the parts which are running in a cluster, you don't want to have the external communication. So there the cluster IP is going to use. Right. So when you want to have the access into the outer world, that's what the node port, which we are seeing right now. Right. Expose the service on each node IP, a static port, right? The node port 30,005, 31,336. Right. So now here a cluster IP service which the node port service routes, it's automatically created. You will be able to contact with the node port. Like as I said, the service will be act as a load balancer. It is going to take care of the load with the help of the particular static node port. We have covered this one. Now the third one is the load balancer. Now here you cannot use that usually in the real time practice. You are not going to use the port IP column the port number, right? So usually you are going to use Flipkart.com, Amazon.com, Paytm.com, like that. So there you require some name, not the IP address. Yes, that's what the load balancer here. So now here you are going to take a common name, a common IP for all of your services. Right. So here the thing is, now this is my cluster, and inside the cluster I have master node, I have worker node 1 and worker node 2. Right. So when I want to access the services into the outer world, right now here I am going to use either master IP then port, or the node 1 column port, or node 2 column port. Right. Anything you can use when it is a node port type. That's what we have seen, right? But in the real time, we are not going to use something like we require a one standard name, one unique name. So that's what here we are going to use a one IP for all. Instead of three individual, I am going to use only one load balancer. And so now it's going to give us only one common IP like 10.0.0.1 like this. So now here earlier we used to use this these nodes IPs, then followed by the port number to access the outer world. Now when I mention I want to have only one common IP for all, not like separate things. So there we are going to use the node service type as a load balancer. Now this load balancer will be provided a name for us, or a IP for us, a IP for us. So now this IP you can use to access the service into the outer world, not the node IPs or the master machine IPs. Right now here the IP is going to change with the load balancer IP. Now the node, now the port, right? This port is going to change. When you are going to use the node port, by that time we are going to use the node port number from the 30 to 32,700, which is the cluster one. So when you are going to use the load balancer, by that time you are not going to use the node port, means if you don't require to use the 30,000 series, simply you can use your expose port like 80 or 81 or something, whatever you are going to expose. Right. So now here the load balance IP colon the port number, what are the expose port number you have mentioned. Right. So that's what the load balance type here. Let's see here. So where you are going to find the load balance IP. So now here the load balance IP you are going to find here external IP. Like cluster IP the internal default one, right? So those will be used for the internal access. Now when you want to access in the outer world, you are going to use the external IP. Now how the external IP will be allocated? When the external IP will be allocated, when you are going to use the load balancer as a service type. Here I have mentioned a node port, that is the reason it is given the internal IPs, no external IPs. Now when the moment I mention I require the load balancer type, then the external IP will be allocated with the port, whatever port you export. Right, so let's see. Right, so a sample application here I am going to take. A simple hello world example of hello world, right? So that is in this repository you can find this hello world deployment file. I apply FNF, right? Means we are taking a file for the deploy. So hello world deployment is created kubectl, like how we did right now, kubectl get all. Now you can see containers are creating. Here is also 5 copies of the containers, 0 out of 5, 5 up to date, but still no availability. kubectl get all. Now 4 are ready, still one more is creating. Now 5 to 5 are ready. It all are ready. You can see 5 are running. So now here you can see the particular deployment of 5 pods creation, and here you can see hello world deployment object you can see, and hello world replica controller you can see, but not the service object. Means the deployment is not having the service object information. That is the reason the service object is not created, only the deployment has taken care, like this. This one, right? With the deployment, it is going to create a deployment object, it is going to create the replica controller, it is going to create the parts. The same happened to this hello world application. So now here, now here I need to create my service object, so that I want to access into the outer world. I want to access it into the outer world. Right. So now for that I'm going to use the type now load balancer instead of the node port. Expose, which you want to expose. I want to expose the deployment object. What is the deployment object here? Hello world, right? So now here the type, what is the type here? Load balancer. Then service, I want to create the service, right? The service, the load balancer belongs to the service object. Name is the type of the name is my service. So now here kubectl get all. Now we are going to see one more service entry for here. Now here you can observe load balancer. Now the node port got changed, and you can observe the load balancer. And here, this is the port which we are going to use now, not the port which is going to allocate to the cluster. So the node port will be utilized when you are going to attach the type as a node port. By that time, we are going to utilize the node ports. Now the port, only what are the port we have given, that port can be utilized when you are going to use the load balancer. That is the difference. So now here you are going to get the external IP to access in the outer world. Now what you will do, instead of taking the nodes IP and the node port, we are going to take the external IP, then followed by the port number, like that, to access. But here, it is not going to create the external IP for us. Always, it will be in the pending state because some configuration is required here. Right. So the some configuration, nothing but this feature is not available in our Kubernets setup. This is the Kubernets setup, KubeADM setup. So now means the normal setup, whatever the cluster setup we have done on that, we are not going to have this feature load balancer. When you are going to use the services, right? EKS, Elastic Kubernetes Service, AKS, Azure Kubernetes Service, GKE, Google Kubernetes Engine. Like the cloud service, if you are using the cloud service, then this feature will be available as a default. Now, your manual setup, like how we have created this cluster, that is not going to have this feature. So that is the reason we are not going to see the external IP feature here. When you are using the services, there you are going to see the external. There the external IP will be allocated. Still on this setup, you want to see this load balancer thing, then we have to set up a separate metal load balancer on this cluster. With now the metal load balancer will be allocated a external IP for us. A separate configuration has to be provided. Has to be configured in this cluster. Then only we can able to see. Right. So that is a different story. If you guys want to interest to see that one, I will provide the link to you guys so that you can go through that link and you can set up it. So that you can see the external IP. Or else with the service you can go to see the cluster. Otherwise, I'll try to see today to set up this one. Tomorrow I will try to explain, but it's a separate configuration again, the external IP. Right. So now here this is the other type. Then the next type will be our what is called fourth one, name, external name. Right. So now even if I use the load balancer type, still you are going to see a external IP. IP only we are going to see. Right. But we are not going to use the IP in the real world. We are going to use the names, right? Flipkart.com, not the IP. Even though I am having the load balancer IP, I am not going to provide IP to my customers. So right. So now this guy has to be attached to the one domain name, DNS name. That DNS name we are going to use to access it. That's what the real time is. Whatever application you are trying to access. Right. So that's what the external IP here. Map the service to the contents of the external field name, like example your site name by referring to a CNM data. Right? We'll see. I will show you this DNS mapping. Right? So if you want to use the DNS means you require the domain name like this. Some domain name you require. Now the domain name we are going to map with our IPs of the load balancer, like what our server IPs. Right? This story will cover in our AWS class how to map the domain names with our cluster so that instead of using the IPs, you can use the domain. Right. So now basically your service in our Kubernetes, the service will be having 4 types: cluster IP, node port, load balancer, external line. Right, guys? This is our interview question for us. Right. So now this is the example, right? And the cleanup. Cleanup, right? So cleanup means you know how to clean the service with the help of delete. delete, you can delete anything. Right, so now the next part. The next part is rolling updates. Right, I want to update my application. I want to revert it. Something is failed. I want to revert it. Right. So your Kubernetes is having a feature, right? On fly can update your applications. On fly can revert it if something went wrong. Right. How to update and how to roll back. We'll see. Right. Let's have a small break here for 15 minutes. Then we'll come back and we'll see the other options of the Kubernetes. Right, yes. So 12:30. We'll be back. We'll be back after 15 minutes.
Okay, sure.
This conference will now be recorded.
Okay, so the updates, rolling updates and rollbacks. Okay, so let's go to our cluster. Okay, so let me see kubectl get all that. We have pods, services, deployments, and duplicate set controllers. So I'm going to clean up all the stuff. So to clean up kubectl delete, right? So delete is a command to delete the objects. So now here kubectl delete. If you observe with the deployment, we got the pods, we got the replicas, and we got the deployments. Okay, so if I delete the deployments, it is going to delete all the three except the service. Okay, so I'm going to delete the deploy, hello world, nginx, sample deploy. Kubectl get all. You can observe here terminated. Right, so the rest of all gone except the service. Everything is gone. Now let me see. Still in the termination process. 4 are left. So this process, if you want to observe, what you can do, you can use watch -w, so that usually this watch command can be observed with the pods command, not with all kubectl get pods. So sometime what will happen, it is going to take some time to bring it up, like terminations and so if you want to watch or how the terminations, how it is going, means how much time it is taking. So there we can use the watch command. So -w, so that it will be in the interactive mode. So now it will be waited. That means it's going to observe every 5 seconds the process like that. So now here kubectl get all, right, except the service, everything is gone. So now let me delete the services. kubectl delete. Either you can use service or the short form will be SVC. Anything you can use. My service nginx sample SVC. kubectl get all. Now everything is cleaned up. So no components are running, nothing here. So now here, wait a second. So now here I want to deploy separately, and I will show, we'll see how these rolling updates are going to happen. Okay. Right, so here let me go to the deployment object. We deploy.yaml file. So here nginx I want to launch. Here my total replicas are 5. Right, so save this kubectl apply -f and deploy.yaml file. And so now it's going to create a fresh deployment for us. For the deployment called nginx with 5 replicas, and the port is node port. Right, so cat deploy.yaml file. Node port is not mentioned. Okay, yes, service, right? In the service we are going to mention node port. Here I have the replicas file. So kubectl apply -f and deploy.yaml file. Deployment is created. Right, so kubectl get pods. Right, so five are running. Kubectl get all. So that again it will show you the same. Like 3 objects are going to create pods. Pods, deployment, and replicas. Now to access into the outer world, right? So we need to have the service object. So let me open the service.yaml file. So here this is the service object. Node port is using. This is the service object, and this is the service name. And my container, like the service label name is sample container, and my app name is sample container. If I open the cat deploy.yaml file, here the label name should be matched. Right? Sample container matching to the sample container. Okay. So now here the service object will be in the node port 3005. So now what I'm doing, kubectl apply -f service.yaml file. Kubectl get all. Right. So here you can see now one more object is created service and with the port 3005. If I go to my browser and search it with the 3005 port, you can see the nginx is reachable. Fine. Yeah, that port, the nginx is reachable. So now here I would like to update the application. Right now rolling updates, right? So here version 1 is running, I assume version 1 is running. Now we want to deploy the version 2. Right. So if you want to deploy the version 2, right. So now here the deployment process you need to point to the version 2, nothing but here in our real time what will happen. So for every CA process, right, every CA, the developer 1, developer 2, developer And so people will be developing the code on the workstations. Then they will be pushed to our GitHub. The source code, the table GitHub version control tool. The code will be pushed to the version control tool. Suppose the developer one is ready with the code. Then what will happen? Our CA process will be triggered. Just pull the code, build the code, push the code into repositories, right? So our artifact repositories. And so this is what our CA process. Simple. I'm not explaining the song and other stuff. You know it. So now here, take the code, pull the code, build the code, and push the code into repo. Push the code means the artifacts here. Right? So push the code means here, which is an artifacts. Artifact repository. So now here, build the code. Right, so now here the build the code means we have seen the build the code, right? Maven clean package. So it's going to create the war file jar file for us. So now here now Kubernetes environment, so we are not going to deploy the war files or jar files. Right, so the microservices. Microservices are going to run in a separate servers. The separate servers we are going to call as a containers. Right. So now on the containers we are going to deploy our code, whatever the code is coming. Right. So on the containers you want to deploy the code means the container is a package of your development code, softwares, configurations, dependencies. All together, it will be packed and the pack will be deployed as a container. This pack will be created as a container. Now the pack we are going to call as a images, Docker images. Right. So whatever the code is pushed by the developers, the code will be pulled here. Then it is going to create a Docker image on top of the code, right? With the help of what? Docker files. You have seen that one, right? Now the Docker files are nothing but take the code and build a Docker image. Right. So now here the build the code is nothing but here it is going to now here the microservice tech terms we are using here now. Build the Docker image. Right. So now here push the artifacts are going to change as push the image into repo. Simple, right? So just yes, a difference is earlier artifacts were used, now images. That's it. That is the key difference between our microservices applications and the normal monolithic applications. Right. So now here the rest of the steps will remain same, no change. Checking the code quality, everything will be the same. Checking in test cases, code qualities, everything will be the same. Just only there the DLLs or WAR files are going to create. Now the images are going to build them. Now pull the code, build the Docker image, and push the image into repo. Right. So now here Docker images are going to build. How? With the help of the Docker files. The Docker files are going to take it here. So now here rolling update means so now here the developer one pushes the code and it will create a Docker image for the developer one code. Right. So now here let's take an example here. Suppose this is developer one image as an example. Now developer two image, developer three. It is pointed to version 1, it is pointed to version 2, and it is pointed to version 3. Right. So now here when the developer one pushes the code will be pulled, and for the code, whatever the developer one pushes the code, for the code, a Docker image will be built and the image will be pushed to the repo with the name developer one image one. When the developer two is going to push the code, now now your Jenkins job is going to run. Now again the job purpose is pull the code. Like now the developer code will be pulled Now for the developer code, the Docker image will build with the name D2 image V2. Something, some name I am going to tell you guys, not the D1, D2, some name you are going to select, credit card image, debit card image, or something like. Then here the versions are going to change, V1, V2, V3. So now here the version 2, then it will push it to the image, right? Now we have 2. Now when the moment developer 3 pushes the code here, and it's going to pull the code and you're going to build the Docker image like D3 image V3. Like for that, likewise, the versions are going to taken care for each and every snapshot, nothing but the images for the piece of code, whatever they have developed. Like right. So now here all the images will be placed in the image repository, like your Docker hub. The Docker hub is a area where all the images are going to store. Correct. So now here image is ready. So now here the version 1 is right now running something like this. Now you can treat this is your version 1, right? Nothing but this one. So now here I update rolling updates, right? So rolling updates are nothing but I want to deploy, like when the developer to push the code, I want to deploy the version 2, the new changes, right? So now here this is what the continuous integration, continuous deployment process for the microservices. Earlier DLLs are going to deploy, or the war files or jar files are going to deploy. Now the images are going to deploy. That's it. The images are going to deploy into the cluster. So now our job is to be wherever you are going to mention that please deploy this image into the cluster. On that area, just you need to change the versions. Version 1, version 2, version 3, like that. Right. So now here you need to change the version 1, version 2, version 3, wherever you have mentioned like please deploy these images into the cluster. That's what you need to take in care. You means as a okay, in our process we need to take in care when there is a code coming into the GitHub, the process will remain the same. Just you are going to update the image details in the manifest files wherever you are going to deploy, where you are trying to deploy with that manifest file, with the help of the manifest file into the cluster. Right. So where this information we are providing in the cluster, so the information of the image will be providing in the cluster is deployment file. Correct. So now deployment file is the one where you are going to mention the replicas information, where you are going to mention the parts. Parts means the containers. Container means you require the image inputs, right? So that's where that is the file we are going to touch to apply the latest versions. Cat deploy. This is the one, right? So now here the image, right? So CCI for image. Now colon version 1 will be there. When the next deployment, when the next changes to the GitHub, now the version 1 you are going to update as a version 2 in our CI/CD process. Now the version 2 will be deployed. Now the something, now again push changes are pushed. Now you are going to update with the version 2 to version 3. Now the version 3 will be deployed. Like that, you are going to set up the process. So right. So now the process we'll see in our CI/CD. Okay, just now we'll see how the rolling updates are going to happen. So now what I will do, we deploy the YAML file. Now here I am going to change this image, right? So to see the case, like so here I'm not going to take in care of versions concept because we don't have any application to see like add a few content and see the changes, right? So we don't have any application to see something like that. That is the reason I'm trying to change the complete image, so that just to I want to see how these updates are going to happen on the cluster, right? How the rolling updates are going to happen. So for that, what I'm going to do, I'm going to change from the Nginx to Apache. Right. So now here I'm going to tell my deployment object deploy the Apache image into the cluster with the name sample container, with the name sample pod, right? Because you are not going to change, you are not going to update the names of the pods, otherwise it will be separate pods again. Now your service object won't understand what is this pod. Your service object has to be understand with the labels, right? So now here only you have to change the input means image, not with the other components. If you change other components, now the linking between the service object, between the deployment object will be broken. Now the service object is not able to pick up your containers, the new containers, right? So now here save it, So cat service.yaml file. Cat service.yaml file sample container, right? So this service object we don't require to touch it, right? So now here, because at the end I am going to access with the same. That's what the updates, right? Flipkart.com is Flipkart.com only. We are not going to say the Flipkart.com to Flipkart.com 1, Flipkart.2 come like that, right? That one. In the background, what are the features we are going to add? That features has to be added to your application with the same domain name, right? So now when I today if I see the GA will be some blue color, some red color, then tomorrow if I see with some white color, some XYZ color, means the updates are happening to the same link, to the same Flipkart. That is the reason service object we are not going to touch. The access will remain the same port, same IPs we are going to use with the same label name. Just only the image you need to be updated. Your code has to be updated. Now your code is nothing but the Docker images. That image has to be updated. That's it. The rest of the things should be the same. Right? The same configurations. So now here I am not going to deploy the service again because the service is already deployed. The service is already deployed and the service is running with the port 3005. Nothing but the Nginx is able to reachable for us. That's what the version 1. If I treat as a versions. So now I'm going to update my version 1 to version 2 means Apache I'm going to launch. So now when the new deployments happen, when I hit the URL, then I need to access the Apache, not the Nginx, because that is a rolling updates. Right? Let's see. So now here just what I need to do here is I need to apply just the deployment. Apply -f deploy. That's it. Right? So now what the deployment will do? It will try to deploy the Apache. Right? So then it will delete the Nginx, right? So now the cluster, what the cluster will do, now this is my cluster and here I have my 5 parts of Nginx with, suppose if I treat it as a version 1, 1, 2, 3, 4, 5. So now this is a set with the version 1. Now it is going to create one more set for the latest, whatever I am going to apply. Right, so now this will be the front end. Service. And so now here this service is mapped with all of our Nginx version 1 containers. Right now, this is what's happening here. So now these are all my Nginx, and these are all my right now the new deployment Apache. Right. So now here people like you and me are trying to hit the cluster to service object. Right. The requests are going to the service object. Now it will be routed to the your Nginx container. That's what the service is going to take care, right, with the help of the node port 30,005. So now here I am trying to update my version 1 to version 2 means I am trying to update from the Nginx to Apache. So what will happen? Right, your cluster will be taken care of zero downtime of the application. We are not going to see any downtime. That's what you need to take care of the cluster. So in the rolling update, what's happening going to here is it is going to create the new set of clusters in the background. Sorry, not the cluster, guys. New set of parts. New set of parts are going to create in the background for your new version called suppose Apache. So now it is going to create the containers. The parts are going to create. Right. So now here the rolling update, what's happening here is suppose a new container is created. One. So now one a new set is going to create for the Apache. Now here what the cluster is going to do. So when the new container is created for the Apache, it is going to delete the 1. Now 4 plus 1, total 5, like this. So when the second container is created, it is going to delete the second 2. Now 3 plus 2, 5. When the third is going to create, then it is going to delete the third one. So 2 plus 3. Like that, it will be taken care of. When the new containers are going to create, the olds are going to delete. So once all the 5, then all the 5 are going to go. So now your requests are going to route from here. Right, so now still the service is same. There is a reason we are not touch the service deployment file. The service will remain the same. Your request will be coming to service, but now the requests are going to the new version 2, not to the old. That's what the cluster is going to do in the background. Right. So here the zero downtime. We are not going to see any downtime. But right, so now here in the background we're going to update slowly, like slowly means one by one, like that, or two by two, something like that, based on the criteria what we have passed it. So now the people, suppose there are 100 people are trying to hit the application, right? In the process, right? Suppose here first one is launched, first one is like fifth one is deleted here. So now out of 195 people are going to get the old request. There is a 5% of people are going to get the latest, but that is not a problem, right? Futures are going to add it. Right. Right. So now, but there no downtime you are going to see. So that's what the class is going to do in the background when you are going to do the rolling updates without any downtime. So now here I am going to launch. I am going to launch my new deployment. Right. Nothing but the Apache. kubectl apply enable. So I have pointed to Apache. I have requested from the engine Apache. Now kubectl apply -f deploy. Now see configured, updated. Now kubectl get pods. Now see here terminating, right? As I said, one will be terminated, one will be created, one will be terminated, one will be like that. It is going to terminate, it is going to create the new ones, right? So -w means I said like watch, so that it will be interactive mode. It will show you what's happening in the background, right? So right, so now here the containers are creating and terminating, create like that. Whatever the architecture we have discussed, like that in the fashion, it is going to create one, delete one, create one, delete one, like that. 1, 2, 3, 4, 5 are terminated. Right. So here 1, 2, 3, that's in the process. Every 5 seconds, it will be watched. Means every 5 seconds it is going to watch the process. Right. So here let's come back. Control C to come out from the interactive mode. Then see kubectl get pause. Come on. Now you can see all 5 are updated. Right. If you want to confirm, right? If you want to confirm, what you can do, simply you can go to the describe kubectl describe pods and hit the enter, pulling the image Apache. Right. Now the Apache is the one which is pulled. So here you can see in the container section, you can see this is the container ID, right? In the background, the container is going to create the image is Apache. Right. Nothing is going to change. App name will be the same, port number will be the same, everything will be the same. Just only the input, the image is going to change. Right. So now let's go to our browser and try to hit the URL again. It was whatever Apache image there, right? So the image is applied. Right, my Nginx is gone. It is replaced with my new code. Nothing but the Apache was. Right. So like you see, you need no downtime, nothing on fly, right? Earlier, if this process if you want to do, right? If I want to do this process, that is a kind of big manual process for us. Load balancer, under the load balancer node, one node has to be disconnected and update it, then bring it back to the load balancer. Again, one node has to be disconnected, update it, bring it back, like that. Without downtime, if you want to do, you have to do this process. Now your cluster simple. Your cluster is going to take care of everything. Right. Hardly it's a instruction to the cluster. What is the instruction? Apply. kubectl applies the command. That's it. This is the instruction we are going to pass by passing the required input. Right. Now that is fine. That is fine. Like now we are seeing the rolling updates. Well, and it's applied smoothly without any issues or hurdles. Now something is broken. When I deploy into the cluster, now something is broken. So now it is not the correct one. Whatever the developers are pushing the code, they said like, no, it is not the correct one. Whatever we are seeing in the environment, that is not the correct one. Something is happened. So please revert back it. I need to fix it that one. Right. So now here reverting back is again a huge process for us. Olden days. Now again say hardly one command. That's it. Right. So how to revert the code back in the cluster from the cluster. Right. So that's what here we have some commands are there to revert back the code to see the history of the deployment process. kubectl. Again, I'm running kubectl. So now here you can see deploy commands. There you can see manage the rollout of a service resource. Rollout. Now kubectl rollout then hyphen help. I want to see how to work with the rollout. kubectl rollout. kubectl rollout. kubectl rollout undo. kubectl rollout status. These are the rollout commands. Okay, so now here it is going to show us kubectl rollout. Then what you want to roll out? The sub command is asking again. Right, so here the sub commands you can see deployments, daemon sets, stateful. Now here I want to see the deployment. So here you can see a rollout undo is the example to roll back to the previous deployment. This is the command. This is just to check the status. Now here there is a command called history. Right. So now here this will be show you like how many deployments are happened. Status, pause. You can pause the providers, whatever resource you are providing here. You can pause it sometime like that. Like plenty of options are there. Now kubectl rollout. Just I want to see the history first. History for what? For my deploy. What is my deploy here? My deployment is sample deploy. kubectl rollout deploy. Sorry, rollout history, right? History deploy sample deploy. Right. So now here you can see how many deployments are happened. There are 2 deployments that happen. So now here, if you want to see more details about the deployments, right? So here we can write the status also, right? While deploying, you can write the status like what kind of deployment, what is deploying here, there, like by using the -" record option. So that by seeing here what is the one or two. Suppose if you are not writing anything, then you can verify the revisions also. So here rollout history, deploy revision equal to 1. Right. So now here you can see if I said like what is the revision 1, what is the deployment. So now here it is going to tell you your deployment is so and so. In the same fashion, if I use revision 2, what is the revision 2? It is going to show you what is you deployed in the as part of the revision 2. Like that, you can check the history of the deployments by using rollout history. And like, if you want to see what exactly the deployments are happened for the revisions by using the revision option, like that. So now here, okay, fine. Now I came to know like, okay, there are 2 deployments that happen. The first one is the older one. The second one is the latest one. The older one is having the deployment of Nginx. The second one is having the deployment of Apache. Now suppose I assume version 1, this is the version 1 and this is the version 2. Now version 2 is having some problems. So you want to revert back to version 1. Right. So for that, you have the command called row undo. Right, what you want to undo? I want to undo my deployment. What is your deployment? Right, my deployment is sample deploy. So kubectl rollout undo. Right. So now here deploy sample deploy. My deployment name. This is my deployment name. Sample deploy. Right. So I want to undo my sample deployment. Right. So what will happen here? So whatever the latest is there in the deployment history, whatever the latest is there, it will be rolled back to the revert back to the previous one. Just one step back to the previous one. If you want to go to the specific one, then simply you need to use -- revision and mention the revision number here, so that the particular one will be, it will go to the particular revision, particular history. If you want to step back, just use undo, that's it. You don't require to provide the option. Fine. So now here I'm going to tell my cluster, let's revert back to the previous change, previous version. kubectl get parse -w. See here, my current parts are terminating and the new parts are creating. Terminating. I did that. Right. The same thing again, right? What happened here is the same set will be there, right? So now here it is going to remove the communications. Again, it will point to the world like that. Like that. That's it. So now here, without any downtime again, your application will be back to the Nginx, your previous version, right? So right. So now here, these parts are going to terminate. These parts will be come back, right? So like that's what happened here. So now here kubectl get parts. You are going to see the 5 again, always 5, right? So now here, if you want to see whether the Nginx is there or not, kubectl describe parts and the pod name, right? Describe more information, more details. Pull the image Nginx, right? Simple. Again, just hit the URL. Nginx is back, right? So right, so see how easily that on fly I can say on fly. On fly you can rolling the updates and you can bring it back also. Just passing an instructions, a commands, roll out, undo, something like that. That's what our jobs become very easy. Always no release engineers, right? So no administrators, nothing. Only the DevOps with the help of these tools. Right? So now here likewise the rolling updates and the revert bringing back means revert the changes with the help of Kubernets by using this apply and roll out commands. Right guys? So this is what the rolling back and rolling updates. This is explanation completely. So now here again we'll see with the CI/CD setup this same process like we'll take our game of life application, then we'll work with the same with the cluster setup, the rolling updates. And now here we'll discuss one more topic and then we'll stop today. So here the other topic from the Kubernetes side is scaling, right? So when I say scaling means, so whatever the pods are running here, right? 5 pods are running here. Now, these 5 pods I want to scale up based on the load. Now we know to scale the pods, right? We know to scale the pods, there is a command called scale, correct? If you want to scale up the, just we have done also in our class, qctl scale hyphen help, right? With the scale command, you can see how to scale up, right? So with the scale command, not only scale up, you can scale in also. Even though you have mentioned desired state 5, with the scale command, you can lower that number also by using, right? So here, you see it here. So now here, right now I have 3. Sorry, I have 5. Now I want to make it with 3. Scale. kubectl get pods. Now you can see the 5 becomes a 3. kubectl get rs. Now your desired state become a 3. Right? I have overwritten with the help of scale. Earlier it was 5. I have changed it to 3. Like that. Like that, with the scale command, we can scale up or we can scale in the parts which are running inside the cluster. Right now we know how to scale the parts. But if you are thinking about the real-time practice, real-time projects, right? You cannot go and do like this manually, right? You cannot, because we don't know when the load will be coming into our cluster on the servers. Right? Maybe morning 6 o'clock or evening 5 o'clock or midnight 2 o'clock. We don't know, right? So by that time you cannot wake up and you cannot run the command scale, right? So that is not the best practice always. Automatically these parts has to be scaled up based on the load, and automatically these parts has to be scaled in based on the load, right? So now here we are going to have some default configuration like this. My default is 3. I require 3. Even though there was a load or no load, at least I want to have 3 copies. 3 parts should be running in the cluster. That's what the desired state. So now we are going to tell your cluster that if the load is bumping or coming into my cluster, scale up based on the load, scale up to what? Max 10. Because my cluster configuration is it can handle 10, it can create 10 containers. Beyond that, no. So now here I am going to tell if the load is increasing, then go for 10 pods. When the load was decreasing, then bring it back to 3 based on the load. Like that, automatically it has to be scaled up, automatically that has to be scaled in. So how we are going to achieve this one? How we are going to achieve this one? So right, for that, in our Kubernetes, we have a concept called pod scaling. We have a concept called pod scaling, nothing but here the pod scaling we are going to call as a here HPA. HPA, nothing but horizontal pod autoscaler. Likewise, we have VPA, virtual pod autoscaler. We have two type of scalings are there, horizontal and vertical. So vertical is another one we are going to use. Vertical means the same resource we are going to utilize, right? The same container we are going to utilize to configure more. For right now, my container is taking 2 CPUs. I am going to increase 4 CPUs. Vertically, we are going to increase 4 CPUs so that you can handle more load. I am going to increase 6 CPUs. Horizontal pod is not like that. We are not going to use the same pod to scale up. Instead, we are going to create separate containers. Separate pods are going to launch with the same configuration. Default, suppose 2 CPUs are going to take for the service means, like it is going to create one more container with the same 2 CPU. Not like 2 will be become as a 4. Right? That is what vertical CPU, vertical scaling we are not going to use. We are going to use the HPA in our real-time practice. So now here, how to set up this HPA? How to set up this horizontal pod autoscaler? So now here, let me kubectl delete deploy sample deploy kubectl. I have deleted the deployment kubectl no this of one because deleted the deployment means it will be gone. Right? Kubectl get SVC. SVC should be there because I am not telling like delete the service object. I can see SVC. That is on file. Now what I will do, create deploy.yaml file. So inside the YAML file, I am going to change the replicas. I am going to make it as 3. kubectl apply -f deploy.yaml file. kubectl get all. So now here, just what I did here is instead of 5 minimum, I have make it as a 3. So it can be done with the scale up also, but I have deleted. Firstly, I have done with the 3 set of replicas. That's it. So now kubectl get rs. Now we are going to see only one entry. Earlier we are going to see 2 entries. When I scaled up or scaled in, we are going to see 2 entry means because this is the default one, 5. I asked for to have the 3. So for the 3, it created one more replica. In the background, it will be having the 5 in the back in the buffer somewhere. So when if I want to have the 5 back, when I do the 5, then it will switch it to this one. So that is the reason I'm going to maintain the backup, something like that. So right, so here I don't want to maintain something like that. There is the reason I have deleted it and separately I have created so that I can see only one entry with my desired state. Fine. So now here I want to do auto scaling. So if you want to do auto scaling, like in our cluster, you have to set up the horizontal pods autoscaler. To set up the horizontal pod autoscaler, So here I have mentioned that process. Metric server setup. Okay, so these steps has to be followed. So here I'm going to use take this first command download URL. Here I'm going to run this download URL. JQ not found. So install the JQ. You have to install JQ. It is somewhere they are using the JQ. So this is not installed on my system. It is going to ask me install the JQ. Right. So in Ubuntu, first you need to update. Then I have to install JQ. Then our command. Right. So here what happened here? Let's say echo. Simply we are taking the metric server repository. So this is the GitHub repository where we are going to have the metric server configuration files. Metric server configuration files. So which we don't require to deal with these configuration files. This is a kind of use setup. Just you can take it and can use it. So now here then I'm going to take the version. So the version can be taken by using this command. Therefore, so this is the version I have to pick up. Then curl-s, the version URL, download URL means this one. From that I ask like install the metric server 0.37 version tar file. If I say ls, right, the file you got it. This is the command. The download is nothing but the repository. This one from the repository I ask you to take the version 3.7. Right, we got the 3.7 for now. So creating a directory for the same. Now we'll extract this one into this particular directory for that tar command. Now go to the metric server. Right. So these are the files which we got from this particular 0.37 version. And so now here I want to set up the metric server. So to set up the metric server, go to the metric server download version is 0.17, whatever the version, 0.37, and from that go to the deployment folder. So this is the deployment folder, cd deploy, and here you are going to see versions, different versions from that 1.8 plus cd 1.8 plus. Here we are going to see the metric server deployment files. So now here this deployment files, this is the metric server deployment file. Right, so here different objects are required to set up this one. Out of that, one is the service account and the deployment object, which we are aware. And here you can see this is the metric server image. And here two objects are utilized. And some configuration. This is the configuration which is required to set up the metric server, which we don't bother about it. So simply what you need to do is you need to apply this one. And so here some changes has to be performed. I think or not, I'm not sure. I'm not sure. See the Jenkins deployment. Yes, let me come back to it. Right, so here we need to set up two parameters, I think, if I'm not wrong. One is get yeah. Right, this is what I'm trying to explain you guys. So HPA. So this code path is not working. That is the reason the step I have provided there. So once you got it, then what we need to do here is in the argument section, metric server deployment file, add the flags. These two has to be added actually. So these two are required here. So here this is the argument section. You can find it here under containers, insecurity ls, and prefer address types. You can see here. These two should be added. Okay. Right. These two parameters are required. So what I will do, I will take these parameters from here, copy, and try to add it here. So or else what we can do here now, we can modify this one also. VI ls metric server deployment file, take this server deployment file VI metric servers deployment file. Then here I will go to argument section. In the argument section, I'm going to add the two parameters. Copy Same indentation. So here I have two arguments, then save this file. Right, so now here again I will go to the setup. kubectl apply. So from wherever the folder is created. Right, so here let me go copy this one and here come back, come back, come back from here, because here I have the folder metric server 037. Apply -f, right? -f apply. I want to apply all the manifest files where metric server -download version, right? So what is the download version means? Our 0.37. 0.37, right? So now here what I'm telling is metric server download version is 03, means go to this folder, inside the folder go to deployment and go to 1.8. From that, whatever the files are there, deployment files, manifest files, deploy it. That's what I'm telling here. So let's take the command, copy. So now here all the manifest files will be deployed, whatever the files are there as part of this HPA deployment. So all will be see, you can see created. If any failures means something is messed up. So now kubectl get HPA. If you want to see our pod details, HPA details, kubectl get HPA is the command to find the HPA details. So somehow it is not showing the URLs. Something happened. kubectl. Let's see, get pause -r namespaces, because it is showing clearly that those are created. These guys are created, but we are not able to find in our namespace. Of here I can see the new cube system, but not our HPA. kubectl get HPA namespaces. Something strange. Let's see. kubectl will deploy open cube system. It is showing that it is deployed in the cube system. Yes, perfect. kubectl get all -n cube system. Correct. So it is deployed inside the namespace of cube system. Correct. Here I did not upload. So here you can see metric server. Metric server pod still in pending status. Pending status. So here kubectl. Let's see what happened to this pod. Kubectl. Describe pod. Then so here not found means the pod is there, but where it created in the namespace called cube system. So now I need to provide the namespace details. Cube cube system. Did not match the node selector. So let me go and see any node selector is there. It is showing us did not match the node selector. CD metric server 037 and go to the deploy. Deploy ls, go to 1.8 ls cat metric server deployment. Here it is looking for the node selector iOS Linux. So this is the reason. So it is saying like this node selector is not matching on any nodes. But it should not be a problem because we have mentioned the Linux on there. kubectl get pods -n cube system. So not able to pick it up. kubectl get pods kubectl describe pods it is pointed to WMV. It is fine. So let's see the issue. We'll take the issue and see. Metric server. So node selected, matrix have been node selected and deployment HTML. Parameter to enable match with the iOS Linux. You can remove the node selector for the deployment. YAML before deployment, you can add those labels to your nodes. Right, this is the solution. Right, if you get something here, it is looking for the Linux node which is not available. So that is the reason it is not able to up. So now there are two solutions. One is you can remove this node selector option, or whatever the nodes are running, you switch left, right? So whatever the nodes in the cluster running, the nodes can be labeled with the property. Two ways, either remove it or add it, right? So now here you can see kubectl get nodes. Right now these nodes can be added with the node name, with the label. Let's try to see. Let's try to add this setup. Master is not required. This is my node name. Giving a label to our node. This is the command. Right, so now here labels are given so that this deployment can switch for the node name like Linux OS, Linux, then it can deploy it. So let's see kubectl get pods -n cube system, because the horizontal part scale belongs to the system component. That is the reason it deployed into the cube system namespace. Perfect. Now you can see it is up and running. Let's now kubectl get HPA. Right, earlier when I try to get the information of HPA, I'm not able to pick it up because that is not running by the time. Now we should get the details. HPA. Still I'm not able to see the information. See what will happen. So anyway, the metric server is up and running, and the parts, right? So metric server part is up and running. Then let's go and see our slide back. This is done. Right, cube system. Right, so now here these are all created, and that will be in the cube system get parts. You can see the part information. Right now we are at the same page. We are at the same. Then the next one, we can check the logs. And so now go to the metric server and see the logs if everything is properly configured and the pod is properly running or not. But if any issues we are seeing means we need to fix it out. And so for that, kubectl logs is the command. Docker logs is the command to check the Docker logs. The kubectl logs is the command to check the pod logs. Pod means again the container. So kubectl logs for what? For your metric server, where the metrics are deployed in my namespace called kube system. Right, general sales and certificates, serving securely on. Means it's properly configured and properly working. Serving securely on, right? That's what we need to see. So then the next step is you can see when the metric server is installed, then we can see kubectl top nodes. Kubectl top pods. We can observe the consumption of resources. Right? Before the metrics are installed, you cannot see the top command. Means you cannot observe the resource consumption, the load information. Once the metric server is installed, then only you can see it. So it is going to capture the load of your node and capture the load of our pods or nothing but the containers. Now here you can see right now I have three servers. That's three servers millicores, 36 millicores, 131 millicores, 35 millicores are utilized. Now the CPU utilization is, you can see, hardly very less because only 5 replicas are containing. So this is the memory utilization at each and every node, and this is the memory utilization percentage. Okay. So here this is the master. There is a master having some huge role because maintaining both the nodes. Now if I go to the pod level, container level, 1 millicore CPUs are allocated. As I said, virtual machines and the containers difference is, for the virtual machines you need to allocate some amount of memory, some amount of hard disk space for your virtual machine, right? Before creating the virtual machine, right? 1.5 GB of RAM or 2 GB of RAM or 1 GB of RAM, right? Or 500 MB of RAM and 1 CPU or 2 CPU of CPUs, right? That is required to create a virtual machine. But in the virtual machine, whatever the service I am running, that is for the service I don't require 500 MB RAM. It hardly require 10 MB RAM. It requires hardly 0.01 CPU. You don't require even 1 CPU also. But for your virtual machine, minimum 1 CPU, minimum 500 MB RAM is required. Right? That's what resource wastage. Right? Even though you don't require that much of CPU and RAM, but still for virtual machine that is required. Unnecessarily, you are wasting resources. That is resolved with the Docker containers. Your containers. Containers are not required to set up the pre-configurations. Pre-configuration, nothing but pre-allocation of the RAMs and hard disk. When the container is going to create, it will take whatever is required. That's what here. Hardly 1 millicore CPU is required for this resource. You just take 1 millicore. 6 MB, MB millicore, right? 6 millicore RAM is required for that. Like whatever is required is going to take it. Right? So once the metric server is installed, then automatically can monitor the utilization of our nodes and utilization of our parts, the resource utilization, right? Fine, this is fine. Then I am going to set up the auto scale on my deployment object, right? So I want to set up the auto scale on my deployment object. So here kubectl run nginx, kubectl get all, kubectl expose, right? We know, right? So now here when I say run nginx means nginx container pod is going to create. Get all means we are going to see pod, service, deployment, and replica set. Now here I want to access it. For that we are using the expose with the node type, with the service type node port, so that you can see, you can access in the outer world. So this process is done from our side. We are done, right? So here, if I go and see kubectl get, or already we have deployed the Nginx with the name sample deploy, sample service, sample deployment, and we have a replica set 2323. This is done from our end. So now here I want to set up my auto scaling. I want to set up my auto scaling, right? So to set up the auto scaling, you need to run the command called auto scale. The auto scale command will work when you set up the Matrix server. That is the link. That is the link to set up the auto scale. So now here kubectl auto scale hyphen help. Kubectl auto scale deployment name, and minimum to max. This is the replication controller. You can set up on the replication controller, or you can set up on the deployment. Right? We are not having the replication controller. We are having the replication set. Replication controllers are the older one. We are not utilizing the replication control now because the replication can be handled with the replication control. Job is to set up the replications. But now with the deployment, we can set up the replication. That is the reason we are not going to use the replication controller separately. We can leave it that one. So now here I am going to scale up my deployment get deploy. Just I want to see the deployment details. My deployment sample deploy, right? So in here the command I am going to use min or right now we have min 3, right? We have right now minimum 3 pods are running, and I want to go with 10 pods. Then here I am going to tell my deployment name is not the Nginx. My deployment name is sample deploy. Right, this is my deployment name, sample deploy. Right, so now right now my sample deployment is having 3. So minimum 3, I want to go for 10. My deployment, I want to do auto scale. Like this is the CPU percentage utilization, right? Because how it has to be scaled up, how the parts has to be scaled up based on the load, right? If my CPU utilization is more than 100%, 80%, then I want to add a node. I want to add a server. That's what the auto scaling, right? So here your parts are running in the background. So now the parts are running with the 1 millicore CPU and 1 millicore CPUs. Right. So now here I'm going to tell if the CPU utilization is greater than 20%. If the right 20% it will reach the CPU utilization 20%, then I want to have a auto scale of the part. Usually the best practice always will be 70% we are going to set up, right? That is the real time. But to see the use case, I mentioned like 20% so that it can be scaled very with less time. Otherwise, we will take for the CPU utilization 70%, then go for the scale. Right? That's now here enter auto scale is deployed. kubectl get HPA. Now let's see. Right. So now here HPA we can see because earlier when I ran the command, by that time I did not set up the auto scaler. That is the reason we did not find anything. So now when I said the get HPA, because right now I have configured, that is the reason you can see the sample deploy. For the sample deploy, the auto scale is set up 3 to 10. Here the targets is showing as unknown. So if the target is showing as unknown means it is not the correct one. We need to do some configuration. It should be shown some percentage. Okay, right? So here what to do for that, right? So here let's see the information kubectl describe, right? We know describe is nothing but to see the more information about the object. So now my object is HPA. Right, so here you can see missing request for CPUs. Fail to get the CPU's utilization. Missing request for the CPU. Right. So now here you can see metrics. The metrics unknown. Right. So because it is not able to get it. So now here what we need to do here is we need to set up your threshold values, your configuration, the utilization of the utilization configuration. Right. So what utilization configuration here is nothing but here whatever the resources the containers are running, for that we are going to set up the limits. If I don't set up the limits, the pod, whatever the pod is running here, right? So let's take the diagram again for better understanding. Suppose assume this is my cluster, 3 nodes cluster, right? So here each cluster is configured with 4 CPUs and some 4 GB RAM. As an example, each cluster is something like that, 4, 4. And this is the master node. We are not bothering about this master node. So now here my pod is running here. So hardly it requires 1 millicore CPU, not even 1 CPU also, 1 millicore. Right. So now here what will happen? Load coming onto this node. Right. So now when the load is coming onto the node, so then it is going to take on this particular pod only. Now the utilization of the pod will become from 1 millicore to 1 CPU. Now it become 1 CPU based on like the load. Now 2 CPUs, now 3 CPUs, now 4 CPUs. It is going to consume more, complete this utilization of the resource of your node because there is no limit on the pod. Now what is the problem here? If it is going to consume more, what is the problem? What is the problem is whatever the other services are running in the node that will be affected. The other containers are going to affect because it is going to take complete resource of the system. When the complete resources are allocated to this container, now these guys are not able to pick the resources. The resources are not left over for this CPU, containers. Then they will start failing. These guys will start failing because no resources are available for this particular container. Because this guy is completely occupied the complete configuration of the node. That is the problem which we are going to face usually when you are going to not set up any resource limits on the containers. Got it, guys? So right, so now here because there is no limit, I didn't mention any limit on my container. So what happened when the load is increasing, automatically try to consume the resource of the system. Now it is going to impact the other parts. It is trying to consume all the resource of the system. Right. So now here for that we need to set up the resource limits. Resource limits. So when you set up the resource limits, then what will happen here? It is going to limit it. So here I am going to request 100 millicore, 100 millicore CPUs. Right. So even the 1 millicore, 2 millicore, that is fine because my minimum is 100. Max how much you want to allocate for the container for the particular part. Right. If the load is increasing, now I am going to give 200 millicore, means that particular container can utilize 200 millicore CPUs of the system, not beyond that. If the load is increasing on the particular container like here, then here my max 1 millicore to I mentioned like 100. That is my max. Then what will happen? It will start with 1 millicore. When the load is increasing, it will go for the 100 millicore utilization. Then it will stop there. It is not going to take any load, so that the other resources are not going to impact. Still, you can have your 4 CPU out of 4 CPUs, only 100 CPUs allocated to this here. Then what next? What next here? Now because you cannot stop the load, when the load increases, then the next will be again take one more container, auto scaling. Now again one more container will be created with the same setup, 1 millicore to 100 millicore. So now the load will be distributed between these containers resources. Again, the increasing the load, one more will come with the same configuration. Now it will go to this one also. That's what the auto scaling, and that's what you need to limit it so that the other services should not be impacted with your services which are coming, which are having the huge amount of load. Resource utilization, resource restrictions. That's what here we need to do. Right. So here let me go to my deployment object. We deploy. We need to add the resources here. Managing the resources. This is what under container. So here I'm going to mention resources. This is what exactly we are looking for. Containers here. I'm going to look for resources. Control C. It should be under the containers. So here it should be the resource limit should be under the containers with the same, right? So indentation has to be followed, otherwise it will throw the syntax errors. It will create a event file. Here apply the event file. Copy. Check the syntax, resources, under that one space. One space here requests. So now here, let's go to our slide. Here here I'm going to tell the my resource are nothing but the CPU utilization. I require the CPU utilization, right? Limits and the request of that CPU utilization I'm going to mention. So let me go here. Here I'm going to change it as department of storage to CPU will be 100 millicore. CPU CPU 100 ml. So now we are going now here by saying this, you will be getting a confusion or doubt like why we are giving 100 because right. So why are you giving to the same? That means my minimum will be 100, my max will be 100. That is something like that. But usually in the real time we are not going to give something like that. Here we are going to give some 500 mAh or 1 CPU or something like that. So that max limitation it can use take that upper limit. This is the lower limit and this is the upper limit. But here to see this use case, I am giving the 100 mAh so that immediately you can get the result. Then
Shankar, screen
save this
structure.
file.
Shankar,
Artiza.
screen structure. Yeah, since the screen got stuck, I think it's issue with everyone also.
Everyone is facing the same, guys.
Yes, Shankar. It's not moving at all.
Okay, let me disconnect and connect it. Now, anything you guys are observing? Cat deploy.
Yes,
Okay.
yeah, it's working.
Okay. Thank you, Rohit. Thank you. Right, so here only the thing what we have done here is added the resource block. Then in the resource block, request and limited the properties. Right, so here your minimum and max, how much you want to utilize. What is the property and CPU. And so now here this has to be applied here. So now what I'm going to do, so whatever the auto scale we have configured, I'm going to delete that auto scale. Then let's deploy it again after the deployment of your latest changes. Right. So now here kubectl get HPA. So kubectl delete HPA deleted. Now so kubectl get HPA. Right. Auto scale is gone. Now let's try to apply our new deployment with the resource of kubectl. So what I will do now, I'm going to change this replicas from 3 to 1 so that the output can be seen immediately. 1 kubectl apply -f, right? -f, then deploy. Right. So unable to parse means if the what is called if the syntax is not properly maintained, then this is the error we are going to see. There should not be any tab spaces here. It should be a single spaces. Let me do one thing instead of wasting the time here. kubectl get all kubectl delete deploy comma svc. I want to deploy my deployment object as well as service object. kubectl get all done. Right, so let's go with the default setup. So what I will do, I will go with our default setup. kubectl run nginx. Nginx is created. kubectl get all. Right now here service object is required to access it. Service object is required. So for that, I'm using the node port. kubectl get all. Now we are going to see 4 objects: pod, service, deployment, and replica set. All are running with 1, and the port is 32617. That is fine. So now here, let's go and set up the autoscaler. Right. So here, before setting up the autoscaler, what I'm going to do, I am going to modify the deployment object of Nginx, and I'm going to add this resources into the deployment. So to modify any object of the Kubernetes, any object, not only deployment, edit is the command. You can get the help from our kubectl edit -help. So now here, my deployment name is Nginx. So now kubectl edit deploy. What is Nginx? I want to modify it. Enter. So now this is the deployment manifest file for the Nginx. By default, our Nginx deployment is providing. So this is not my own, not by me. This file is created. This is the from the community side. So now here from that, here you can see containers, right? So here I'm going to add termination message policy file. So somewhere we are going to see termination message policy file, this one, which is under the containers. So the same only under the containers. So here and here I'm going to add resources. Or yes, for your CS resources, then limits. CPU 100 ml and under the limits requests. CPU, that's it. Resources, limits, CPU, request CPU 100 ml. Then the DNS policy, right? This is the DNS policy. Let's save it. Right. So if you edit, you can deployment unable to pass the quantities. Nginx could not be patched up. main the problem is the indentation. If something is not given properly, this kind of errors you are going to see actually. So again, I need to provide it. Let's try one more time. Otherwise, we'll stop it today and we'll see tomorrow this one. Let's see. So this. Okay. I think the properties are not accepting right now. Maybe those are changed in the versions. Okay. Okay, guys. Anyway, the time is running out. We'll see this tomorrow class. Okay. Today we'll see how to fix it, and we'll see this one tomorrow. The horizontal product scale.
Okay. Thank you.
Okay. Thank you.